and I was in Escalante, Utah. And I was 6 miles out of town, and the spoke on my back wheel broke. And it was a bad break, and it caused my wheel to bend too. So it wasn't just the spoke fall off, but the spoke, when that fell off, it bent the wheel. So like, you know, lift it off, it spin, it just wouldn't spin. And so I needed a new wheel. The wheel was completely shot. So I hitchhiked back into town, and, you know, did some searching around. The closest bike shop was 150 miles behind me in Cedar City, Utah, or it was 400 miles in front of me at my final destination. So, okay, so, you know, how am I going to get there with a broken bike?
So tell me more about your life. Tell me more, tell me more. So tell me more about your why. Tell me more, tell me more.
Welcome to Miltakaev podcast. My guest today is Aidan Ramey, who's a great friend, NASA electrical engineer, and as he calls himself, lover of difficult things. The first half of the podcast will go into his experience at NASA, the projects he's currently on, such as Project Viper, which is the lunar rover under Artemis program, and other projects. In the second half, we'll go into his personal journey on challenging himself physically and mentally, and at the same time, raising money for charities. He has a lot of wisdom and learnings and great moments of humanity and connection, especially in the moments of need in these stories. So I really appreciated the latter half as much as the first one. Hope you enjoy. So, Aidan.
Emil.
Thank you for coming to the podcast, or actually hosting in your own garage.
Quite literally, yes.
So we know each other from 2017, right? Back when you were an engineer, electrical engineer at UC Davis, majoring in.
Correct.
And now you are electrical engineer at NASA.
That is correct.
So tell me more about how you came from the passion for space into actually living and working the dream.
Yeah, so I was always into space as a kid. Star Wars movies were my favorite growing up. So I think that was sort of the beginning of my love for space. And always had in the back of my mind that I thought engineering would be something that I'd be good at. I built model ships as a kid, was into puzzles, was into Legos, was very quick to assemble those things with no trouble. So I always knew that building things was something that I enjoyed doing. Then I took an honors engineering class in high school, where I got to do soldering for the first time. And I thought soldering is the coolest thing ever. I want to do more soldering. And I thought that's all electrical engineering was soldering.
Isn't it that all it is?
It is a small portion. There's a lot of math. And that is not what I realized when I signed up for the electrical engineering major, was how much math was going to be into that major. But that sort of, that class got me into, okay, I want to be I'm pretty confident that this engineering thing is for me. And then in high school, it was my junior year, I listened to a talk by Mike Massimo, who was one of the astronauts on the Hubble Space Telescope. He was one of the ones that went in when it had its big fault with the power system. He went and went on the spacewalk and repaired it. So he came to a local high school, and I listened to him talk for hour and a half, and then I was like, okay, that's what I want to do. I want to work for NASA. I want to be an astronaut. I want to do something along those lines. And that was sort of like an aha moment for me, and that's what I want to do. So came into Davis as an electrical engineering major, declared that and stuck with that all 4 years. Lots more math than I was initially thinking that the major was going to be. But through caffeine and hard-headedness, I was able to survive that. And my sophomore year, I joined the Space and Satellite Systems Club, which at the time was this small club of 15 or so students. And they had, just saw a flyer in one of the buildings of the engineering wings, and went to a meeting because I thought this could be a good way to start building up some space experience, because there was nothing in the electrical engineering major that had anything space related into it. I thought about going to aerospace, but after talking to the advisor, just the classes that were there weren't of interest to me. Dealing with aerodynamics and that kind of stuff didn't interest me. I always liked electronics more. So went to the Space and Satellite Systems Club, sophomore year, tiny club. Had these big dreams of what they were going to do, that they were going to build a satellite for UC Davis. But they did have some alumni working at NASA. So I thought, oh, that's cool. Maybe there's some connections there. And then throughout my tenure at Davis, that club just got bigger and bigger, to where, it was 15 people. And then my senior year, it was 60 or 80 people, and all engineering students, and, had various teams of various subsystems. And because I was sort of on the ground floor, if you will, of that club, I rose the ranks there and became the electrical lead, and got to do design work and then manage the electrical team of, I think towards the end, it was around 20 people. And that club taught me a lot about space systems, do's and don'ts, and all the intricacies that you have to think about when dealing with a system in space. And because obviously once it's up there, you can't go up there and fix it. It's not like a laptop where you can just take it apart and at any time and swap a component. Once it's up there, it's up there. And so I joined that club because I thought something good might come out of it, and it did. One of the alumni of the club, who was working at Ames Research Center, which is where I'm working now, he invited the club to take a tour of Ames, which was very exciting, and did a tour of Ames, and I think there was 10 or 15 of us who came on the tour and toured a couple labs, saw a bunch of cool stuff. And I came into it with, since I was the electrical lead of this satellite that the Davis team was building, I came into it with a bunch of questions. I was told that there was going to be an electrical engineer there, and I just wanted to ask as many questions as I could. Because sure, you took electrical engineering classes, but that doesn't really tell you anything about the real world. Education and real world experience in most cases are very, very different. What I learned in school, sure, I used some of the stuff I learned in school, but that club and then my internships and my lab experience in college was way more useful to my current job than any of my classes were.
So that helped bridge the gap.
Yes. That club, in that club, I was designing circuit boards for satellites, which is what I'm doing now. So, I didn't do any, PCB design, printed circuit board design in any of my classes. That was all through that club. So, we had the tour and pegged down the electrical engineer, asked him question after question for half an hour, just me and him talking, asking electrical questions. And at the end, hey, do you need an intern? I said, I do need an intern, and I don't want to sort through a stack of resumes, so you got the internship. So on that tour, what's the harm of asking, right? So I asked and got the internship. And the internship was awesome. This was 2019 when I interned. And Ames was fully open. There was all these activities going on, and during the summer, when there's interns there, it was so alive. There was all these. There's a big lawn towards the front gate, and there was all these big barbecues and picnics and all these activities, and there was, happy hours with $2 drinks, and there was, each organization, the engineering director had a barbecue, and the engineering director had a ice cream social, and then the information technology directorate had a barbecue. So there was so much social interaction, plus the cafeteria, and there's the bar on base, and so there was so much interaction there, which was really nice, and allowed for a lot of networking and a lot of learning and this conversation. And I think that was wonderful, because you got to experience with, or talk with, so a lot of international people, which I was not expecting working at NASA. There's a lot of international people working at NASA.
Does that interfere with the license for?
No, I mean they don't really,
citizenship requirement.
Yeah, so no, there's like some foreign national status that you can be and work at NASA. And on my previous team, there was a guy from Spain, a guy from Germany, a guy from South Africa, a guy from Vietnam. There was all these international people, and usually what it is it's people that are at the top of the field and want to work at NASA, and because they have this expertise, they figure out the way to get them to work there. It's obviously much harder to work there as a non-American citizen, but if you got enough cred, then you can do it. But yeah, my internship was awesome. Did a big wide variety of things, which I really appreciated. Both electrical things, hands-on stuff, testing, lab work. Really enjoyed the internship, and at the end of my internship, didn't get a written offer, but I got a verbal offer that, hey, once you graduate next year, we'd love to have you for a full-time position. And that happened. I graduated in June, and there was a federal government hiring freeze because I graduated in June of 2020. So they weren't hiring people for I think right when COVID started, they did the hiring freeze, and then I didn't get hired until August 1st. So a few months of a hiring freeze. They weren't sure what was going on.
Were you nervous at the time?
I was a little, probably not as nervous as I should have been, if I'm being completely honest, because I just thought, I had the verbal offer. I'll get the job, nothing. And my brother was like, do you have anything in writing? Like, no, I don't have anything in writing. I'll be fine. I trusted my boss at the time. And, but I was lucky that my intuition was correct, and that a couple months after I graduated, got the full-time position, and have been there ever since, about 2.5 years now, at Ames Research Center here in Mountain View, California.
It's very cool.
Yeah.
You mentioned that it had like a lot more festivities back then. Has it not recovered since COVID?
No, it's the bureaucratic gears of the federal government turn slowly. And especially when it comes to non-essential things like employee happiness. So barbecues and, the gym just reopened 5 or so months ago. The pool, there was a pool, it was a really nice pool on base, and it was much cheaper than the community pool. And that has been shut down, and they have no plans to reopen it anytime soon. So that could be, another year or two. The gift shop apparently is opening next month. So, we're I guess 3 years after COVID hit. Because it happened mid-March, right, of 2020. Yeah. So,
anniversary.
Yeah. So we're 3 years since the start of COVID. The gift shop is still not open back, so that'll be another month. All the summer activities, like the summer softball league, that's not back. All those picnics, all the barbecues, things like that, are very slow to come back. The one thing that is coming back is the happy hours have started. I think this month, it was 2 days ago. I think that was the third one they did. And So that has just started again, the monthly happy hours. But the bar is only open, for breakfast and lunch. The cafeteria on base is still not open. So a lot of the amenities that allowed you to interact with people who aren't on your team, aren't on your project, who maybe work on the complete opposite side of base, but you were right behind him in the burrito line, so let's sit together and talk. And it allowed for a lot more collaboration between buildings, between divisions and directorates. And also just due to the nature of remote work, that has stopped a lot of people coming on base.
Yeah.
NASA is now I think 25% fully remote. Plus, on top of that, you have all the hybrid people.
What kind of hybrid? Is there a specific model or it's flexible?
At this point, as of now, it's flexible. It depends on which center you're at, if you're a contract, if you're a civil servant. There's very much in the gray area. But most people are in a hybrid setting. I am in a hybrid setting. Because of the nature of the work I do lots of hardware, lots of hands-on stuff. So I'm on base most days. Usually it's, work from home Fridays or a Monday. So usually once a week I'm working from home, and then the rest of the time I'm on base, which I don't mind. I'm a 5-minute drive to work, which is amazing. Yeah, after growing up in LA where you're driving everywhere and a 30-minute drive that's a short drive. So, having a 5-minute drive to work is really nice. And then to bike to work is 20 minutes, and it's all either bike trails through the Google campus, which is very pretty, or like protected bike lanes. So it's a very pretty, very safe bike ride to work. So I feel very lucky that, 20-minute bike or 5-minute drive, super easy to get to work. And, and obviously I don't have to worry about my bike getting stolen there because there's multiple layers of security with guards with guns there. So I'm not concerned about my bike getting stolen.
Serious business.
Well, it's, we do share Ames with the military. So Ames Research Center is NASA, as well as the Air Force and the Navy also have a presence there.
Okay. I'm not feeling threatened. As far as, is it the only Northern California center for NASA, or?
Yes. Yeah, the only Northern California center. There's JPL in Pasadena, and they do lots of rover-related things. They spearheaded a lot of all those Mars rovers, so they've done a lot of great work there. You have Armstrong, which is north of LA, sort of out by Palmdale. I think a little north of Palmdale. I'm not exactly sure, but they do. They have a lot of runways there, so I know they do lots of space/plane stuff. I'm not exactly sure what they do there. I've never interacted with someone that works at Armstrong. And then you also, I guess it's not really technically a NASA center, but out of Vandenberg, which is right next to Santa Barbara, it's actually a launch site. So that's where SpaceX has launched a lot of things. Firefly, which is an up-and-coming rocket company, they've launched a lot of things out of Vandenberg. And so yeah, some of my coworkers' projects have launched things out of Vandenberg. But in terms of proper NASA centers, it would be in California. It would be Ames, where I work, in Silicon Valley, JPL in Pasadena, and then you have Armstrong north of LA, out in the desert out there.
Cool. I wanted to ask, in terms of the specifics of the job, it's a very high-level description that I understand so far, but what does it actually mean, like working on a satellite as an electrical engineer?
Yeah, I mean, it really depends on where you are in terms of the project, which I really appreciate. It's not the same thing every day. So if you look at the life cycle of a space project, you have the conception, planning stage where maybe you're writing an idea. Oh, this would be cool if we did this experiment, or what if we did this payload on a satellite? A payload is like an experiment you put on board of the satellite. So not the entire satellite, but just like a box that you would put onto something else. So you have that stage where you're thinking about the idea. Then you have the design stage where, electrically speaking, you're drawing schematics. You're working in PCB software like Altium, and which I wish I was using Altium in college. But
So a tip for college students.
For young electrical engineers, know how to use Altium, and that will be a huge skill for you. And probably through education you can get an Altium license. You have free software like Fusion 360 that works well. My first circuits I designed in Fusion 360. But if you get your hands on an Altium license and learn how to use that, that is an incredible skill that I'm very lucky to where I have a pretty good hands-on Altium, and it's very, very useful. It's a very powerful tool, both the schematic view, the PCB layer view, and then also the 3D modeling view. And then it also integrates with SolidWorks very well. So you can design everything from schematic, all the layers, the copper layers, and then look at the 3D, like what does it actually look like, and then you can import that into SolidWorks very easily, which is like the Premiere CAD software. So Altium is great. So you have the design stage where you're doing that kind of stuff. You're working in Altium. You're thinking about schematics. You're thinking about the system. You're thinking about what it needs to be, and that can be But those first two stages can be very remote. Those can be where you're working at home. You can really do those anywhere because that's very computer heavy work. Then you start like the prototyping stage, right? So you're starting to buy, not flight grade components, some cheaper components, some cheaper PCBs, and you're getting your hands on. Maybe you're not going to the assembly houses who build up these circuit boards in a, very professional way to save some money. Maybe you're hand soldering the components on and testing it, like, oh, what does this configuration work? And so you're starting to go into the lab more. You're testing your circuit boards, you're testing instruments, you're testing, you're testing sensors, you're testing whatever it is in the lab.
Do you have to emulate the environment in space, or you can just test it?
At that stage, not really. No, you're still just trying to get the things to work. You're prototyping. This doesn't work. Okay, well, let's send out another revision. Let's get a new circuit board, or that part doesn't work. Let's swap on a different part. So very hands-on, very experimental, seeing if things work. And one of the projects I'm a part of is in that stage, which is pretty exciting. There's a lot of testing, building. This doesn't work. Let's try this slightly different configuration. Let's see if that works. And then you have, so things are starting to go well. You start to get the flight version. So you have all the EDU, you have the prototype, then you have the EDU, it's kind of the same thing. EDU for educational is kind of slang. There's so many acronyms at NASA. It is the most acronym driven environment. That is, it can be a little wearing and can be very confusing for people that aren't in the NASA ecosystem. So if I ever say an acronym that doesn't make any sense, please stop me.
I will.
But yeah, so then you do the EDUs, work on those, try and get those to work. And that's where you're really, nailing down on what works, what doesn't work. You start to deal with trade-offs for mechanical. Okay, you can have this perfect electrical solution, but it doesn't fit. Well, then it's not a perfect solution. If you have to think about things mechanically, you have to think about things thermally. Thermal is a huge thing in space. Thermal management. If you
overheating,
overheating basically, because you have no air to take the heat. A laptop, if you just sit it on a table, if it's hot, you sit it on a table, you turn it off, it's going to dissipate heat right into the air, and the heat will go away. If you have a hot satellite, and you turn it off, it's just going to stay hot. You know, you have to do something with that. You have to
Because
think,
it's sealed.
well, there's no air.
Yeah.
There's nowhere for the heat to go. So it you'll have to deal with, things cool down
By interacting with.
right. So you have to do things to deal with heat management, and then also things will get very cold, you know, because space is very cold. So you have to deal with you have to think about things thermally, like, okay, you know, maybe this is the best electrical solution, but I'm putting all these components all super close together, and it's going to create this super hot thing, and it's all stuck in the middle. What you need to do is you need to get that heat to the shell of the satellite, and then that'll kind of allow it to dissipate if it's on the metal shell.
Yeah.
But if it's in the internals of the satellite on all the circuit boards, the heat very much stays there. So it's all about trying to get that heat to the outside.
To me, as someone as an like outsider, I'm surprised that this hasn't been resolved since like Voyager still work and they've been designed forever ago. And wasn't that a problem back then as well? And
Well, yeah, I mean, there's tried and true methods on
but it's
ways to
always
handle
hard
it.
every time.
But yeah, I mean,
Yeah.
it's always something you have to consider. It's
Yeah.
not like you can just, not think about thermal. You know, you always have to consider, okay, where is my heat going? Where are, if you're, sometimes you get something called, you can be completely lit or completely dark for long periods of time. So, like, can your satellite handle that? Like, okay, well, because of the orbit of things, of sun, earth, satellite, all that kind of stuff, your satellite could be completely sunlit for 3 days, and it's going to absorb heat doing that. And it's great for your solar panels, right? Because you're getting all this power, but you're also absorbing heat doing that. So can your satellite handle 3 days of heat? On the inverse, you also have, okay, well, due to orbits, yada yada yada, we're going to be dark for 2 or 3 days. Got to make sure the batteries don't freeze. With lithium-ion batteries, once they freeze, they crystallize. Once they crystallize, they stop working. And once your satellite doesn't have batteries, you're kind of SOL. So the
Meaning?
So then you have the EDU stage. So then you get into flight hardware. So this is, okay, this stuff is going up. So flight hardware, you can be a little bit more loosey-goosey with prototype EDU hardware. You can be hand soldering things, and that doesn't work, just swap that, or not have to worry about cleanliness too much because, well, it's not going anywhere. It's staying on the worktop bench, right? So as long as it works, it doesn't need to look pretty, basically.
Yeah.
Whereas your flight builds have to be, perfect to the letter, no small mistakes, nothing. Because this is, and you always have multiple versions of flight stuff, because, shit always happens. But, your flight build has to be, perfect. You're sending your PCBs to PCB manufacturer and assembly houses that solder it perfectly, and with no mistakes. And you test you want to sort of interact with the flight hardware as little as possible. So you have your EDU units, and you sort of get it to a point where, like, okay, this is really good. So then once your flight hardware comes, you can plug it in and unplug it as little as possible. So
you don't even want to like wear and tear.
Right, because the more every time you unplug and plug in a connector, you're adding some sort of risk. Yeah, obviously it's minimal, but sometimes the little metal flaps on connectors break off. Like, well, that was our flight PCB, so it's like, you want to try and mitigate that as much as possible. And then once you're done with the circuit boards, you have to conformal coat them. So you basically you cover the entire circuit board in a layer of epoxy,
which is a material.
Yeah, so that's like a plastic cement. That's an epoxy. Super glue is technically an epoxy. It's a liquid plastic thing that it's an adhesive basically,
okay.
And epoxies is very much a general term, but the conformal coating epoxy is there to act as a protective layer. So kind of seal everything in. So you have no chance of, you know, a component. So let's say, you know, you have no chance of a component breaking, and then, you know, imagine a little resistor tinging around all inside the satellite, you know.
So you
wreak
can
havoc.
keep it in.
So it seals everything.
seals, yeah.
You know. So imagine like those acrylic tables.
Yeah.
Right. That's an epoxy acrylic. So imagine dunking a PCB in that liquid acrylic, and then you have like, you know, a plastic block basically, and it's a thin layer, so it's not like a big rectangle, but it is, you know, it covers everything in that plastic layer, so nothing can move. And obviously, you know, that's one of the final steps, because once you've dunked everything in the plastic, you know, it's you kind of.
It's like freezing the board.
Right, yeah. You're freezing the board, and you can, you know, scrape off the conformal coating, but, you know, you don't want to do that for flight, you know. Once it's there, it's done.
But before you get to that point, how do you get from how do you get to manufacturing? You just send files and online things you've built, like in the software.
So everything is in Altium.
Yeah.
Okay. Right. And so that you have your schematics, which are, you know, this resistor goes into this IC, which goes into this connector. So that's, you know, the hand-drawn, you know, circuits, you know, that kind of stuff. That's the schematic view. Then you have circuit board design is kind of two beasts. You have your schematic view, which is more where the math goes in. You know, if you have a filter that needs a certain resistor to get a certain bandwidth on some communication system, right? So you have to think about that. But there's nothing physical about it. It's all this is what's going to happen. Is all the math. This component needs to connect to this in this way, and these are the components we need. And then you have the second half. So everything. Okay, this is what it's going to look like, right? But then you have the entire second half of, okay, but how do you actually put it together? Because you're basically laying out this drawing of this is what it should be. And then you have, okay, well, what does it actually physically look like? So a typical PCB will be 4-layer circuit board. So that's 4 copper layers, 4 internal copper layers.
On top of each other?
Yeah. So, you know, it'll only be, you know, 1/8 of an inch thick, I think is the standard for PCBs. I should probably know that. But yeah, so you have, you know, 1/8 inch, 1/4 inch thick, whatever it is. And, you know, 4-layer, you know, 2-layer PCB is kind of the most basic way. You have your top layer and your bottom layer. So that is what allows you to have components on the top and bottom, because you have 2 copper layers, right? But then you can have internal layers. So you have other layers in the middle. So let's say you want a layer that's all the power lines. Because if you have real thick traces, which are basically flat wires, you know, if you have real thick copper traces, it's a lot more power efficient than having little wires, you know, because it has a lot more resistance for the power. Yeah. So you usually want to have a dedicated power layer, and you usually want to have a dedicated ground layer. But let's say you have a really complicated circuit board that's got a microcontroller and it's got a radio on it. Well, you know, that's got a couple hundred pins on it. You're gonna need more layers. Then you get into 6-layer, 8-layer PCBs. You know, I assume theoretically, you know, you can do as many as you want. I know in the real world there's probably a limit of, I don't know. I've never heard of one going over 12 or 14 layers. I'm sure there are PCBs, you know, it wouldn't surprise me if, you know, you get 20-layer PCBs. It is economically not viable to go for a 20-layer PCB, because that is incredibly hard to manufacture. With every layer you're increasing, you're getting a bigger lead time and more expense. And that's one of the things you have to think about with circuit board design, is you have to think about things, you know, electrically, how does it make sense? Thermically, how does it make sense? Mechanically, how does it make sense? And then also you have to design for manufacture. So you have to think about, okay, you know, how much is this circuit board going to cost me? You know, how much is a 4-layer versus a 6-layer? And, you know, I can buy a couple more 4 layers instead of a 6-layer if I design it the right way, and that allows me more boards to test with. And so, yeah, design for manufacturing is a big thing in PCB. So, yeah, so you have that schematic, which is the first head, and then you have the PCB design, which is my favorite part, which is the PCB design. And the layout is what it's called, the layout version, or the layout part of the circuit board process, and that is very much like a puzzle, because you have this, you have this square rectangle, and so it starts you with this, blank rectangle, and all the components you design all off to the left, and it's your job to, physically place them all and figure out how they're going to connect, right? And how it's all going to fit together. And you have all these things to think about, like, okay, well, you want, so you sort of start to group the components together, like, okay, well, this is all part of this filter, so these all components kind of have to be together. You have these capacitors for inrush current. You need to be close to the connector, so when you plug something in, if you have an inrush of voltage, it doesn't blow anything up. So those capacitors physically have to be close to the connector, so you have to think about things that way. And so you start to move components around. Okay, we'll put it here. Okay, well, I guess this can go on the other side, and you have holes that, little vias that you can send a copper trace, which is a trace, like I said, basically a wire. And that's how you have these lines that connect all your components. And so you design things, okay, and it's true that an aesthetically pleasing circuit board is usually a more functional circuit board. Obviously, there's exceptions to that, but if everything is neat and tidy, you have a lot less room for error. And you can see when people are reviewing it, you can see, okay, it's clear that these things are going here, and this makes sense here, and it allows for better design reviews, and allows for an easier test. Because a big a thing I really try and focus on when I'm designing my circuit boards is, okay, when this circuit board is going to someone who has never tested a circuit board before, would they be able to test it? So in that PCB view, you can put like writing on the board, right? So you can name your connectors, or plug this in here, or you have like this LED is if the power is connected. This
like the legend sort of.
Well, I mean that's more like notes you would have, but like like physically on the board you have like white. It's basically white paint, for lack of a better term. That so when you're assembling it, you put R1 for resistor 1, R1, R2, R3. So like if you're testing, like, oh, I think R3 is wrong. So it's easy to think, versus if there was no writing on whatsoever, you'd be like, what is this? Versus if you had an abundance of writing, it's like, okay, this is labeling. Okay, this is this board, this is this revision, this is this serial number. Okay, and on the board, it's like, okay, this connector plugs into power. Great. So then, if someone who hasn't, because, you could hand this board off to someone who didn't do any of the designing, so they know nothing about this board, but they should still be able to look at it and say, okay, well, this is power, so this plugs into power, and this, okay, so if I want to, change something in the microcontroller, this is the connector for that. So it allows for a lot more ease of testing. So that's the sort of process when it comes to designing circuit boards. It's an enjoyable process. The layout process is much more like puzzles, which is why I like it, because you have to think about, there's a lot of give and takes about, okay, I want this component to be closer to that for the communication benefit. The filtering will be better, but if it's there, it could get in the way of something else, mechanically speaking. So you have to sort of do give and takes there, and kind of move things around and try and fit things and try and cram as much as possible on these little circuit boards, because in most cases you don't have a ton of space. At least the stuff I'm working on, the satellites I'm working on are the size of 2 loaves of bread, so they're what's called CubeSats. So much smaller, and so you really have to design small stuff.
Speaking of, well, first of all, really sounds really cool. Like a challenge of having to fit all that stuff, and a lot of priority setting what's important. And it reminds of that local maxima at each point. Like you want to figure out how much you can get out of each, but not overdo it to have the overall best quality, like iPod and iPhone,
right?
Instead of just doing one thing, and it will not work with everything else that you have to consider. I wanted to ask you for the satellite size. Is it common? Because I used to have a misconception that satellites are really huge, always.
Yeah.
They have to be like ginormous and hard to launch. And what's the current
So that was
world of satellites?
usually the case. I mean, Sputnik was, I don't know, like the size of half this table, I think. But so, satellites got bigger and bigger and bigger until they were these big behemoth things. And then it was like, well, why don't we just send smaller stuff, because it'll be much cheaper. So that's kind of been the trend of satellites over the past 15 years or so, is, getting smaller satellites. So you have different sections. You have CubeSats, small sats, microsats. I'm not sure exactly what the barrier between those are. There's some size barrier, but it's much cheaper, first of all. So when they're much smaller, it allows you to experiment a lot more, do a lot more technology demonstrations, test new things. And if it doesn't work, well, a little satellite that's, the size of a shoebox, let's say, maybe that only costs you a couple $100,000 versus, when AT&T, for example, sends up a satellite, they're sending technology up, even currently, like when AT&T is sending up like a new satellite, they're sending out 20-year-old technology because they know it's going to work. They know it has flight heritage, which is a big thing in the space industry, is, has it launched before and does it work? Flight heritage is huge, especially for private industry, because they want it to work. So when AT&T sends up the satellite, they're sending up a satellite the size of a school bus that costs $400 million. Whereas, the satellites I'm working on, they're the size of, 2 loaves of bread and costs a couple $100,000, maybe $1 million or $2 million. So much cheaper, and allows you to, test new technologies, like brand new chips, brand new microcontrollers, work with NVIDIA and try and, hey, let's send a graphics card up into space, that would be cool. Or let's, one demonstration that happened a few years ago was a project called PhoneSat. And it basically, they just took apart at the time, took apart, the most modern phone and see if they could use all the internals of a phone to run a functioning satellite as much as they could. And it worked.
What is the definition of a satellite then? I'm just curious. If a phone
I can Google it. But no, the definition of satellite, I assume, because you have satellite, because you have a more general definition of things where, like, I think you have like satellite, like asteroid and satellite planet. So satellite, I think, just means something
that
small
orbits.
that orbits. Yeah. So I think it doesn't necessarily have to be technological. I think the satellite definition technically, like a satellite office is like a small offshoot, right? So,
but in the context of a phone being able to be a satellite means it can beam back.
Right. So usually
data.
it's, communication, right, is arguably the most important part, because if you can't communicate with it, then why is it up there? So it has to be able to communicate with it, and usually it has some sort of experiment or some sort of function on board. Obviously, AT&T satellites don't have experiments on them. They're there to, collect and transmit signals for many years. But, the stuff we're doing, we have, you have maybe you have a couple science experiments on board. Maybe it's a couple cameras, maybe it's a new radio you want to test, or maybe it's maybe it's a new chip. Who knows what it is? So maybe you can have a couple experiments on board, and then you have you kind of have what's the bus, which is the main everything that's not the experiment. So that's your batteries, right? That's usually your communication system as part of the bus. Sometimes you have like a payload communication system, but if you got your bus batteries, your bus communication system, you've got your solar panels, because the thing is, you have you have the structure, right? So you have all these things that just you need it up there to function, and then you have as a separate component is the payload section. So you have the bus section, which is what allows it to work, so you can communicate with it, so it runs all that. And then you have the payload section, which is your science experiment or science experiments.
What are the current, I guess, the ones you can talk about, the science experiments that are taking place, and where's the innovative stuff?
Yeah,
right
so
now?
I'm currently on 3 different projects, which is super exciting. I am working on one of which is a lunar rover. So that is launching sometime 2024, 2025, it depends on how things go, but that's the
NASA timelines.
Yeah, if launches slip, that's one of the nice things about working for NASA is you're not making a profit.
Yeah.
So if things slip, then it's okay, because it's not, you don't have like a customer to meet. It's because if you're going to spend all this money to put a rover on the moon, there's no sense in rushing it and then it doesn't work.
Yeah.
So yeah, I'm working on Viper, which is a lunar rover, and that's about the size of a golf cart. And I can send you a picture of that. Also,
Yeah.
There's a full model of it on base. That's really cool, and they encourage you to take pictures, and you can share it on social media and all that kind of stuff. So
Insert into the podcast.
insert picture of the golf cart sized rover. So I'm working on that, and then I'm also working on a project called Leia, which is a lunar biology experiment. And that is going off the BioSentinel experiment. So BioSentinel is a satellite that launched recently, and that is using yeast cultures. And BioSentinel is testing yeast cultures in deep space, whereas Leia is testing yeast cultures on the moon.
In the moon's
So it's going to be on the surface, yeah. So the Leia is still sort of in that prototyping stage I was mentioning. So there's no launch date on that yet, but the idea is, yes, for it to be on some sort of lunar lander. Viper, what that's doing, why are we sending a golf cart sized rover on the moon? And this is not an astronaut's going to be driving it. This is like controlled here. The point of that is to looking at the moon in terms of resource extraction. So looking at ice, looking at water, looking at rocks, looking at what's there in a certain in a certain area of the moon.
to mine.
Not really to mine, but the Artemis program, or not? Artemis program.
The moon base?
Is sort of the sort of overarching big thing that's going on at NASA. You had the Apollo program, right? Yeah. That was, get us to the moon, all these rockets, all this cool stuff. And then, you had a couple other ones, but right now, just recently started as the Artemis program. And the whole idea of Artemis is really focusing on the moon. Let's try and set up a permanent presence there. It makes a lot more sense if you want to explore the solar system. It makes a lot of sense to start on the moon because it's only like a 3-day journey versus going to Mars, which once every 3 years is a 3-month journey. And if it's outside of that, then it can be up to a year journey or plus. I'm not exactly sure on the orbit, but, much longer than 3 months. So, it takes forever to get to Mars. And obviously much harsher environment. I mean, you can't breathe on either, but with the winds
and delay,
and you have because it's so far away. The speed of light. I think it causes like a 10-minute delay or something like that.
Yeah, it's like one way 10 minutes, and then
So if you want to send a command to your robot on Mars, you send the command. and 10 minutes later, the command is going at the speed of light. 10 minutes later, the robot gets the command.
So far.
Yeah, no, the solar system is huge. I mean, you see those solar system maps and like in your bedroom, all that kind of stuff, and everything's so close together. Now, one of my favorite websites is like, I think it's called like Scale of the Universe. And you know, this Earth is the size of 1 pixel, and you like hit the scroll button and like how long it takes you, and it takes you know like a couple minutes to get to the moon. And you think of the moon like, oh, moon's really close, right? No, the moon's not close to Earth. And then, you know, it takes you like half an hour to scroll to, you know, some of the other planets, you know, to like, I think Mars takes you like 5 or 10 minutes to like, and you're scrolling like not, you know, you're clicking nonstop, just like, and it's like flying. And remember, the Earth is 1 pixel, right? So yeah, space is mostly nothing.
Yeah. And speed of light is very slow, actually.
Right. Yeah. So, but yeah, so long story short, you know, Viper's looking at, you know, ice. Look, it's got some spectrometers, got a drill on there. And also, you know, if you're going to the moon, you know, you want to start building up a moon base, you know, it doesn't really make sense to bring lumber to the moon, right? So if you're, the last time I read, I'm sure it's updated now, but the last time I read, it's like $40,000 per kilogram, everything you want to get into orbit. So, you know, if you're sending raw materials up there, you know, it sounds very expensive. Yeah. So let's make moon bricks, you know. Not that that's, you know, sort of the goal of the mission, but that's, you know,
it's being cost effective.
Yeah. You know, it makes a lot more sense to use what's there and see what's there versus to bring everything up. You know, it's a lot more cost effective. And you know, try and use the ice that's there for drinking, or use the rocks that's there. If there's metal there, you know, use that there rather than just, you know, bring everything up. So looking at, you know, the first sort of moon mission to look at the moon in terms of resource extraction. Again, not resource extraction for profit and like, oh, let's get gold on the moon, but more in the sense of, you know, using what's there to build something for us to continue to use.
You mean there's not going to be extraction of precious metals?
I had to sign an NDA. That's classified.
Well, that's why I'm here.
Yeah. So that's Viper. Then I have Leia, the lunar biology experiment. And the last one is Helioswarm, which is a big project that is very much in the early stages. You know, Vipers, you know, I didn't finish all the stages of the work, but you know, just for quickly, you have your flight hardware, then you have your INT, which is integration and testing, final testing, screw it all together. Then you have the launch, and then you have mission ops, and mission ops is, you know, controlling it on the ground. So you have that whole life cycle of design, prototype, put it all together, and control it, right? And Helioswarm is still very much in the early stages of, you know, requirements writing, and I believe hardware is being built, but you know, the hardware is not being built by NASA. It's being built by big contractors.
And the gist of Helioswarm is?
The gist of Helioswarm is it is a 9 satellite array, orbit halfway between Earth and the moon. And it's looking at it's studying the sun, and it's studying plasma, and it's studying the magnetic. I learned a new word for this project, actually, magnetohydrodynamics. So it's the way that magnetic fields and plasmas interact in a fluid, and so studying those effects on a mass scale, you know, between small to, you know, small being, you know, tens of kilometers versus, you know, thousands of kilometers, you know, this 9 satellite array that's, you know, got this crazy complicated orbit, you have the 8 daughter satellites plus the 1 hub satellite. And so it's studying the sun, in layman's terms, it's studying the sun and all the plasma and magnetic fields that it gives off and how it affects things like the Earth. So it's the first really massive study on the sun and how it affects us in space and on a big scale. So, if you just have one point, you can only get so much data versus if you have like a swarm of satellites, all in, complicated, thought out orbits that make certain designs, it allows you to study a lot more versus just one, because if you just study one point, that could be an anomaly or that could represent everything versus if you have a swarm of satellites, you get a better picture of how things are actually are affected by the sun.
So technically, like one satellite that looks at the sun might not get the, solar flare that the other can get.
Right, exactly. And maybe you're in a zone that has a very weak magnetic field, but 1,000 kilometers this way, it has a very strong magnetic field. But if you're always moving around and rotating and, getting the swarm smaller, getting the swarm bigger, and then that whole swarm is orbiting the Earth, so you're getting so many more plots of data versus just having that one satellite orbiting. You just have that one data point. So yeah, that is Helioswarm. It's a bunch of satellites studying the sun and the plasma and the magnetic field that it gives off. And that one, that's not planning on launching anytime soon. I mean, 2026, 2027, who knows? So that's sometime in the future. But much more earlier stage than the other 2 projects I'm working on.
Cool. Do you have a preference, like your favorite project that you're most passionate about? Or
no, I wouldn't say so. No, I mean I like each one gives me different things to work on, different challenges, different approaches. My start of NASA, I was just working for CubeSats, just small satellites, and I learned a lot, and I loved working on that. But I knew I wanted to work on other stuff too. I knew I wanted to work on some sort of rover project. Excuse me. So getting the opportunity to work on a rover project is awesome, and I'm super excited that I'm working on a rover project.
I mean, it's crazy. You're contributing to something that's gonna go on another object.
Right. It's
like mind-blowing.
It's gonna be driving on the moon, like collecting data, and I'm gonna be touching it and assembling things on it.
And then you're gonna look at night and see a rover.
Yeah, exactly.
Maybe, I don't know. Which side is it going?
I don't know. It's a good question.
No one really goes on that side, really.
Yeah, I think the majority of the moon stuff has kind of been in the lit sections.
Yeah.
Versus the dark side of the moon, but
which is not.
It's a great album, but but yeah. So no, I mean, I'm very happy working on that. I'm excited to working on Helioswarm because I'm having more of a systems engineering role, so a little bit more high level than just hands-on electrical engineering. I'm looking at requirements. I'm looking at telling the defense contractors, this is how you need to be designing your things, and this is how you need to be testing your subsystems and things like that. So a semi-managerial position, if you will, but looking at the system more of a whole rather than just focusing on the electronics. And Leia is the one where I'm the most hands-on for, 'cause we're prototyping. It's a much smaller team. Viper is across 5 or 6 NASA centers across the United States. Helioswarm again is across multiple centers, and international Helioswarm as well. Like there's parts of the satellite are from Europe, like the instruments on it. So huge teams. You have hundreds and hundreds of people on these projects. So much bigger scale, much bigger funding, versus something like Leia, where it's there's like 20 of us, right? And we're all at Ames, and we're all trying to get this thing to work. And So yeah, each project gives you different challenges, different things to think about, different objectives, different timelines. That sort of progression of things you're doing. Each one is kind of in a different stage, which is an exciting thing. So yeah, no, I wouldn't say I have a favorite one, but I really do get. I'm very thankful that I am on all three projects. That I have the opportunity to work on all three of those projects, and that I'm just learning so much in all three of them. So I'm very happy with my work situation currently.
That is awesome.
Yeah.
Yeah, it's really cool stuff.
Thank you.
Speaking of funding, you mentioned overall might not be your area of expertise, but do you think that NASA would be able to do far more if it was receiving more government support?
Oh yeah,
financially?
without a doubt. I mean, you think about the federal budget of the United States. NASA gets 0.5% of the federal budget, and yet we're still able to run all these science experiments. And, it's just the three projects I'm working on are, a drop in the bucket of all the NASA stuff that's going on, all the satellites that are in orbit, and all the experiments that are orbiting the moon or in deep space or the James Webb Telescope. I mean, look at how awesome that is. The pictures that's getting. I mean, all the amazing science that's going to come out.
Didn't
of
it
that
say
telescope.
like one picture of that is more than Hubble's, like so much of Hubble's data?
Right. It's an order of magnitude higher quality than it is Hubble, because it's it's so much further out and the lens is so much bigger. When you have it's so much further from Earth. Hubble is like in orbit, or pretty close. Pretty close, as in 700 kilometers from the surface of Earth, versus James Webb, which is hundreds of thousands of kilometers from the surface of Earth.
Where is it in the solar system?
Don't quote me on this, but I'm pretty sure it's somewhere between the Earth and the Moon. But I'm not exactly. I know it's much further away than. Like the International Space Station is like 750 kilometers. Most of the CubeSats that use stuff, it's all in what's called low Earth orbit, which is 500 to 800 kilometers. Somewhere around there. Where that is much further.
What do you consider space? Where is the line?
I don't know. Whatever. I mean, I would think something that. For a non-technical answer, I would say space is, if you can't breathe, there's no oxygen, and you can stay in orbit for, a month, let's call it, without coming into re-entry. Let's call that space, whatever altitude that is. I don't know exactly what I know there's all those stratosphere, magnetosphere. All
the
those.
American astronaut who didn't technically become the first man because he was not in space, right?
Now we got some Soviet-U.S. rivalry coming back. Okay.
So, I was just curious.
But yeah, no, I do not have a firm opinion on what the border of space is. I know there was some arguments on whether the billionaires going to space, if they really went to space or not. I don't know. I mean, I think if you're in orbit and you can stay in orbit, I would consider that space. If you can be in an orbit and stay in orbit, whatever that height is, I would assume that's somewhere in the scale of a couple hundred kilometers. I think I shot in the dark. I have never really heard of things orbiting at 400 kilometers. So I would think, whatever the start of you can orbit would be space, for a long-winded answer. Yeah.
Before we wrap up the satellites topic, I want to ask you, as a person who worked on a lot of satellites, do you think it is a problem that there is a lot of satellites left over and just
space trash? Yeah, space trash is certainly an issue, and that's a big problem to be solved, is space trash. And you can look at a cool visual thing online. It kind of looks like Earth has Saturn's rings with all the trash we have in space. It's over-exaggerated with the size, but Yeah, and you know you're constantly seeing. Just recently, the International Space Station had to make an emergency maneuver to avoid some space trash. You know, NASA, as of I don't know when. Wait for the car to go by.
It sounded like it's gonna launch.
Yeah, NASA, as of semi recently, everything has to have a deorbiting plan. So everything. You know, all the
Into the Earth or outward?
yeah, so like at least for things in low Earth orbit. So you know, the previous CubeSat I was working on, you know, you have to have some plan where it's going to burn up so you don't create space trash. So nothing can be, you know, unless you have special exceptions, nothing can be in space for more than 25 years now. It has to, you know, the previous satellite I worked on, it had a, depending on if the solar panel is deployed or not, it would burn up between 6 and 9 years. So, you know, well within the 25-year time frame. And, you know, because most of these missions, you know, a couple months, you know, a year max of the actual science. So yeah, all these have to have deorbiting plans. So it's sort of like retroactively making, or it's, you know, in the future it's like reducing more future space trash, but it doesn't do anything about the trash that's already there. So yeah, everyone but China follows that rule of stuff has to burn up within 25 years, so you're not creating more trash.
Is there a way to create like sort of satellites that catch satellites?
I mean, that's one of the ideas, you know, big nets of things, but so much of the stuff, so much of the space trash is, you know, the size of quarters, right? And it's not like all the space trash is all bundled up in a nice pile, right? You know, you have one piece of trash the size of a quarter that's 50 miles away from another piece of trash that's a quarter, you know? And, you know, so it's a complicated problem that they're continuing to try and, you know, there's no perfect solution for. I know people are working on it. But yeah, it is certainly a thing that people are, you know, it's continuing to grow, the space trash. And, you know, people are trying to think of ways to reduce it. And it is certainly a problem. That we need to continue to think about and how to reduce it. But then you also have to deal with things like, you know, that an AT&T satellite that's the size of a school bus, that's not going to burn up. You know, that is so big that it's not going to burn up on reentry versus my little satellites of 2 loaves of bread, you know, that's going to burn up no problem. But so they send those to like a graveyard orbit, they call. So they just send it even you know, they save little fuel for end of life on that giant satellite, and they send it out another, I don't know what the graveyard orbit is, but they send it out further out, and that will, you know, in thousands of years will not burn up. It kind of just sticks in that graveyard orbit. But, you know, if something breaks in the graveyard orbit, maybe it can come from the graveyard to the low Earth orbit and hit the International Space Station. So it's a complicated issue. The biggest, you know, problems of it is so much of the space trash is so small and so far apart. So it's not like you can just like get a net and scoop it up. You know, you have to, you know, everything is so small, so far apart.
How much damage can that quarter do?
A lot, because it's not just me throwing a quarter at you. It's me throwing a quarter at you at 16,000 miles an hour. So even,
like,
you know,
so much faster than a bullet.
Even if it's really, really small, you know, even if your mass is super, super small, if your acceleration is super, super high, and force equals mass times acceleration, even a tiny pebble going 16,000 miles an hour can rip a hole through, you know, International Space Station. So they have to be very, very careful of stuff. And, you know, their solar panels are constantly getting hit by stuff, and they're, you know, constantly having to make repairs to it because of stuff hitting it.
Wow. Is there like a agreed guideline on which way things should rotate? Or do satellites go clockwise, anti-clockwise around the Earth? Or, I mean, it's probably the wrong term to say.
I don't think I've ever been asked that question.
Like, Earth is rotating.
Sure.
And which way do satellites go? if they just stay depending from the point where we are, something can just stay still.
I get what you're trying
right?
to ask.
What's that? Or you can move, right? And what decides that? Do you decide ahead of the project, like that's part of the parameters?
So, I know everything that the U.S. launches sort of comes out the same entry, more or less the same entry. 90+% of the stuff we launch comes out of Florida, right? And it's coming out of Florida, and it's going in its one direction. It kind of pushes things in that one direction in that one orbit, right? Okay. Are there other organizations that launch stuff? If we're launching it this way, are they launching stuff that's going this way? Yeah. I don't know. I don't know any of the numbers of 60% of the stuff is going clockwise versus counterclockwise. I don't know, but I do. Yeah, I know that there is stuff going both ways. It's not something that I've ever dealt with in terms of it's not really in the design process or thought process of, okay, this satellite's going clockwise or whatever it is. It's just going the way it is. But yeah, I'm quite confident there are things going both directions. But in terms of more than specifics than that, I unfortunately do not know the answer to that.
Thank you.
Yeah.
Yeah. I just thought of it, so
yeah, no, it's a great question. It really is.
So, wrapping up the NASA things.
Yes.
What's your advice to inspired up and coming people who want to, or even just anything, to do anything with space? Mm-hmm. What would you say, like a good point to start? You're in school, high school, or even earlier?
Yeah.
Or later. Yeah.
Right. There's so much. One of the cool things about NASA is the stuff that we make is for the general public's benefit. So if you think about the technology behind a pacemaker, right, that all started at NASA. Obviously, famously Velcro, right? A lot of the miniaturization of technology was really spearheaded by NASA. So even now, you can look at once the science experiment is done, NASA will just put that data out to the public. So, because I was just looking into this recently, Landsat, which is a hyperspectral imager satellite. You can look at Landsat and look at the data that you can just take all the data and do stuff with it. Mm-hmm. So, looking at, what previous space missions have done, there's a lot of stuff online where you can do like citizen scientists, and you can actually look for stars. It'll have these big pictures, you can identify a couple stars, and and that actual data does go to NASA scientists. So that you can get some information there. In terms of working there, you have the vast majority of the people working there are engineers. So if you're looking to a degree, the vast majority people have engineering degrees.
Which type of engineering?
It really isn't a specific. One of the pieces of advice I got from Mike Massimo that I would pass on is find what interests you and do that, and figure out a way to get that into space. You can be a mechanical engineer because you need to design structures for satellites, or you can be an electrical engineer because you need circuit boards and power for, satellites. You can be an aerospace engineer because, you have to deal with aerodynamics and the size of things. If you actually want to work at NASA, the aerospace engineering, funny enough, is actually the one I would least recommend. Because it's kind of like a general major, and a lot of the stuff in terms of actual space hardware you don't use because you're not really dealing with aerodynamics because you're in the vacuum of space, so you don't have to deal with aerodynamic issues. That's probably the engineering degree, funny enough, I would least recommend is is that one. But, electrical, mechanical, software, obviously there's so many software positions. All these satellites are all software, very heavily software driven, right? So yeah, electrical, mechanical, software, or computer science. I guess if you were looking to degrees to do, that would be kind of the ones that would be most applicable to the things. So at least the things I see, with aerospace, if you want to deal with the actual rockets, that's what I would. But I don't deal with rockets. I deal with the things the rockets shoot up. And then, getting involved, like what I did, it was a club, and figure out ways to do some sort of space work or join some sort of space research. There aren't a ton of classes in most undergraduate programs that are like space centered. Cal Poly San Luis Obispo has an amazing space program. They've launched a bunch of satellites. I would look at university, like if you're applying to college and you're in that stage, I would look at universities that have space labs. University of Georgia has a very proficient space satellite lab that has launched a lot of great stuff. Like I said, San Luis Obispo. There's a lot of spots in the Midwest, North Carolina. There are schools that have these space labs. UC Davis just recently started one. So, I would look to schools that have that space lab or space lab, and try and work into that, because that's how you get, because at NASA they want to hire people with experience in the space industry, because it's a very niche field of engineering. So look for clubs, groups, labs, things like that allow you to get some hands-on experiments on what it's like working with space systems. And then with that, USA Jobs, right? That's how you get a lot of internships. You have, you can go through the contractors. That's a good way to do it. Try and get on a base somewhere is look at some of these, not a big defense contractor like Raytheon, but like a smaller one like KBR. KBR is like at every NASA center, and but,
get your foot through the door.
Yeah, get your foot through the door through a contractor and get some work in there, and figure out some way to do it there. Yeah, I would say the university way is, with getting into the space industry, it's very much an industry where you need at least a bachelor's degree. You don't really see people that don't have that. Some people do have more advanced degrees, master's, PhD. You don't necessarily need it. But getting that bachelor's degree allows you to get into those clubs and those space labs. It allows you to do research, things like that. And then, find some sort of research group that works with NASA. And then you work with that research group, then you start working with NASA. Then you start interacting with NASA. And, that's how you get your foot in the door, which is the way I did it. And, because, NASA very heavily works with research institutions, colleges, universities, things like that. So, find a university that does that, first of all, because there are some universities that just have, 0 space programs. So find a university that does have a space program. And, I guess you could start one, but it'd be much easier if you go to one that already has one. And, join that club, do that lab or whatever it is, and again focus on the side of engineering that you like. If you like mechanical engineering but you think, well, maybe electrical engineering will give me a better chance, like, no, just find the one you like, get really good at that, and then do that. Because a couple of the astronauts were biologists. They didn't do any engineering. Now, there's a lot less biology jobs at NASA, but, there is a rodent research division at Ames, so there are biologists there. So find a field of science that you really enjoy, whether it's physics, engineering, whatever it is. Focus on that, get good at that, figure out a way to, work with some organization that works with NASA, and then that's how you end up working at NASA.
makes me want to start the journey all over. You just started masters, right?
Yeah, I started my master's 2 days ago. My master's in electrical engineering, of course, through George Washington University out in DC, and that's going to be 100% remote, which will allow me to still work full time, take one class at a time, and if it takes me 2-3 years, 2 or 3 years is an entire scope of my life is not that much, and allows me to advance more. It helps me to become a better engineer. When it comes to design, a lot more knowledge. I'm focusing on power and energy systems. The Hubble Space Telescope failed because of its power system. Every single satellite, every single rover, every single thing in space has batteries on board and has a power system. So it's a very useful topic. So yeah, I've just started my master's in electrical engineering, focusing on power energy systems. Taking it, part-time, one class, not a semester, technically it's a term. So one class per term. Optional summer if I want. I can double up on classes if I'm really feeling gung-ho about it. But for now, just taking one class, it's been, 2.5 years since I've done school. So I don't want to, dive into the deep end. And, so start with one class at a time. If, that's a good amount, I'll just stick with one. And I think if I just did one, it would take me 2.5 years. If I start doing more classes, or maybe I want to take a little time off, I can do that too. So it allows me to be very flexible, which I like, but still increase my knowledge as an electrical engineer. Introduce me to a lot more topics that maybe I just brushed upon in undergrad, but really get to focus in on. And, puts a little bit more, beefs up your resume, of course, which is always good. Now is a good time to do it.
Investment into yourself and
exactly,
future.
Exactly, investment to myself, to my future. Exactly. So, So I'm excited to start that journey.
Which also says something that you mentioned before, that NASA is good at work-life balance, where you have that ability.
Yes. If I was working in a if I was working at SpaceX,
that was the
not to throw
elephant
anyone
in the room.
I love SpaceX. They have, we get to use American rockets again because of SpaceX. They're the most reliable rocket taxi service on the planet. And they're the cheapest because they reuse their rockets. And when SpaceX sends up a rocket for their satellite taxi service, they launch 80 satellites at a time. So it's not just one satellite bolted to the rocket, it's 80 satellites bolted to the rocket. And it goes up in low Earth orbit, shoots everything out, comes back down. Super cool. Love SpaceX. Would never want to work there. Because, Elon demands a lot of work. You got to work 60, 80-hour weeks, right? And, versus NASA, the flexibility is there, right? If I have a doctor's appointment in the middle of the day, I just go to the doctor's appointment. I make up the hours somewhere else. Because there's no profit incentive, it's not as high paced as, a lot of the startup life here is in Silicon Valley, I have friends that are like, oh, well, I got to work this weekend and I don't really have a choice because otherwise I don't have my job. Where it's like, no one's really forcing you to work weekends, maybe at the very end of, integration and testing. Yeah, there's always exceptions at the end. Like, well, we got to get to this environmental test. We're just at the end life cycle of the project, and maybe once it's up there and it's a really critical time once it's when you're doing some mission ops. But, the norm is it's a, very manageable work-life balance, which is really nice. And, so, allowing, it would be a lot harder for me to get my master's online if I was working at a startup or something in private industry than working at NASA, where I have a lot more flexible schedule, which is one of the great perks about my job is it really is a flexible schedule. Yeah, and if I know I want to work from home, if I want to travel somewhere, like, I can work from home for a couple days while traveling. So I do my hardware stuff at the beginning of the week and save a bunch of computer work, whether it's paperwork or design work, whatever it is. Save that all to the second half of the week, so I can be in Tahoe and working and still get stuff done. But then close my laptop at 5 and go get to hang out in Lake Tahoe, something like that. So yeah, the flexibility of the work is very nice.
Yeah, it's a big perk to consider.
Yeah.
For sure. Now, switching gears a little bit, want to talk about your incredible love for challenges.
Yes.
And physical challenges, pushing your, I guess, mentally yourself. And I mean, maybe that also can, in surprising way,
for
interact
Buzz,
with your work.
Close this garage door.
Yes.
To totally interrupt you right there. Sorry about that.
It's fine. Do you want to close it?
Yeah, let's take a brief pause.
Okay, sure.
Thanks to our sponsors, Kind Bar. Yes, you were saying.
Yeah, the physical challenges.
Yes.
You are a big lover since Davis, maybe before, because I always knew you liked to challenge yourself. You were part of the triathlon team at Davis. You did some crazy things, and I sometimes got involved.
Yes.
Like Murph challenge.
You did a Murph with me.
Yeah. And now
fun.
you're doing 75 hard, and you're on the 62nd day of a 75 challenge,
Yep.
75-day challenge. And please go ahead and explain what that is and your general love for those things.
Yeah. So I was, I guess my fitness journey has, started, like most kids in an elementary school doing baseball, doing Little League as it's called in America. You do soccer, did a little basketball, did your general stuff. But I was never super focused on it. It wasn't like a thing I was really driving. My brother from day one was a baseball player since he was 6 years old, and he played baseball all the way through college, and went to the Division III World Series for his baseball team. He was baseball from day one, loved baseball as a kid. I was never really into sports as a kid. As for all the physical stuff I do now, I was never really gung ho about sports. I was, but I did it, because it's what you do, and and I enjoyed the social aspect of it. And then I got into theater in performing arts in middle school, so I didn't really do any athletics in middle school. But then I got it in my idea that it would be cool to be the kicker for the football team. So I thought, that's what I'll do. That's what I'll train for. So I went to a kicking football camp and started working towards that. And I thought, okay, well, I'll build up my leg strength by joining the track team. So freshman year, I joined spring track, and really enjoyed the environment there. I had a wonderful coach, Coach Troy Samuels, real supportive guy, just a sweetheart, and I appreciated, similar to my college coach, he pushed you as much as you wanted to be pushed. If you wanted to be a star athlete, he would help you get there. If you wanted to show up once a week and just be there to hang out and get a little workout in, he was totally fine with that. And everything in between, if you wanted to show up 3-4 days a week and take it semi-seriously, whatever it was, he supported you in that endeavor. So that sort of started me on the track of athletics again, starting that in high school. So I did track and cross country all throughout high school, and really enjoyed that. But I wouldn't work out in between. So I would do the couple months of track, not work out for months, and then a couple months of cross country, and then not work out in between. So you kind of go up and then down, and then up and then down, and up and down. So was never really a crazy athlete in high school, but the summer before my junior year, I was working 40 hours a week at McDonald's, just hating life. So I was depressed from that. I had a unfortunate incident at my junior prom that made me feel really physically weak because I couldn't pick up my blacked out date from the after party. I couldn't physically pick her up, so I felt very weak from doing that. And then the McDonald's, and I had my first panic attack that summer because I was dealing with standardized testing, getting into college, and I didn't know what a panic attack was. So with that and the McDonald's, I felt very emotionally weak and very, so I just felt, I went to sort of deep depression that summer, and was pretty challenging for me. So I wanted something to focus on because working 40 hours a week at McDonald's sucks. So I'm not exactly sure. I think it was a family friend that, we were talking. She came over and, she knew I was a runner. Like, oh, you should try triathlon. So signed up for a triathlon, gave me a goal. Completed my first sprint distance triathlon at the end of that summer before senior year. Okay, this is what I want to do. And the sense of accomplishment while finishing that was unlike anything I had ever experienced before, because I spent the summer training, I swam 750 meters, I biked for 12 miles, and then I ran for 3 miles, and I finished it, and it felt great. And, and it was, something to work on, and yeah, so it was awesome. And so doing that, I immediately knew, okay, this is what I want to do. And I did another triathlon the summer before going into college. And so then, like you'd mentioned, I was on the triathlon team all of college. And that was kind of when I started to take athletics seriously, was starting college. Because I was training 10, 12 hours a week in college. Running, biking, swimming. I didn't start lifting until like sophomore, junior year. But for injury prevention, I wish I had started lifting earlier. But yeah, so I started doing triathlon, really started taking that seriously, and really fell in love with that, and loved the challenge of it. Loved the challenge of endurance athletics, of just, that slow, continuous burn, that when you go on those multi-hour bike rides and you're just, your legs feel like they're fried, but you just keep on going, you keep on pushing, you just keep on, push through any of the lactic acid pain. And so I really enjoyed that aspect of triathlon. And, I enjoyed, I'm a very goal-oriented person when it comes to fitness. It helps me maintain consistency a lot, is if I always have goals to reach towards. So that's what I really liked about triathlon, is you sign up for these races, months, sometimes a year in advance, and, they're not cheap either. So your cheapest
you're committed.
Yeah. So you're emotionally and financially committed to do these races.
How much is it?
The cheapest race, you can do is like $100 versus a full Ironman costs over $1,000. The half Ironman I did was somewhere in the $350 range, the 2 half Ironmans I've done. So you have this goal months in advance. Like, okay, well, I don't want it to be brutally painful the entire. I want to enjoy the race and like be able to actually push myself, not just survive it. So it forces you to train through it. So I really like that. You have that goal and you're working towards that.
Yeah.
And so I did triathlon all 4 years of college. Went to nationals twice. My senior year, my healthiest year, my fastest I ever was. But COVID happened, so I didn't get to do regionals or nationals. So super big bummer. But yeah, so that was, the start of my serious with athletics, was doing triathlon, being a part of that team environment that, where you have people to push you and go faster.
How much faster did you get from where you started to where you were at your fastest? So
I guess the one indicator I had, I guess I have a couple indicators, but my high school cross country time PR versus my 3 mile PR in college dropped by like 4 minutes for over 3 miles. I did the same race, so just not even at my peak. I did the same race before my freshman year and after my freshman year of college. I did the same race, an Olympic distance triathlon, and I dropped 45 minutes.
Wow.
And that was largely due to the fact that I had zero swim training before, and then I had a year of like, this is how you actually swim.
How long is the swimming part?
For that distance, the swim is 1,500 meters.
Okay.
So, you know, I was grossly unprepared the summer before, but just I learned the difference between, I know how to swim versus a proper workout swim are two completely different things. You know, I went to college, I know how to swim. Everyone knows how to swim, right? But then you go swim workouts where you're going back and forth, you know, 2 times back and forth, and I was gassed, right, at the start. But by then, at the end of, you know, at the end of the season, you know, I could do, you know, 10 laps in a row and be fine. You know, I could swim 1,000 meters in a row and be fine, and you know, and not just be fine, but be able to push myself through those thousands of meters. But before, I could do 50 meters and be struggling.
And that is after you done running or
so swim, bike, run is the order of it.
Swim, bike. Okay, you start with swim.
So start with the swim.
Is it always that order?
Always swim, bike, run.
Why?
Because putting on a wetsuit after you just bike for a long time sounds pretty miserable. Because putting on a wetsuit is because there's usually open water swimming in like a lake or or the ocean. So putting on a wetsuit takes time, and you know it's real tight, right? So having to do that in the middle of the race would be a pain in the ass. And that's also technically the most dangerous part. The part where most people die is the swim. And it's usually old people that overestimate their swimming capability and, you know, drown. But
I didn't know that about triathlon.
So the swimming is technically the riskiest. I mean, sure, you have bike accidents because you're going, you know, pretty fast. I mean, you know, depending on the race, you can get up to 40 plus miles an hour on the bike.
That's faster than speed limit in some areas.
Yeah. So, did swim, did triathlon, and then I had mentioned, you know, my regionals and nationals got canceled. Devastating. I felt like I'm in such good shape. I'm fine because I struggled with injuries. Freshman year was all about learning the sport, and then you know, learning the techniques, and you know, getting a good baseline for me. And then sophomore year nationals, I got a terrible injury, and then that stayed with me all of junior year. Senior year, I was finally healthy, finally ready to race, super excited, and then you know COVID canceled it. So I felt like something was missing, some hole was missing. So I felt like I had to do something. I had to do something to. It was probably also a mix of going crazy because of COVID and lockdown, but I felt like there was this big hole missing after not being able to race regionals and nationals. And so I did my first challenge. So I'd done, it's a type of workout called the Murph, where it's named after a Navy SEAL. And I'd done it with you twice before I'd done a Murph. It's a Memorial Day workout where you run a mile, you do 100 push-ups, 100 pull-ups, 200 push-ups, 300 squats, and then you run another mile. And you do that for time. And
you add a beer to it.
that was a different challenge.
Really?
Yeah, no, that was, I'll get into that one. But then, this one was no beer. This was just mile, 100
That's
pull-ups.
a pure version, then there's an Aiden version.
That was a different challenge. I'll get into that. But mile, 100 pull-ups, 200 push-ups, 300 squats, run another mile. Do it for time. So I'd done it a couple before. And then... So I started like doing online research, like what are fitness goals? What are, you know, big thing, you know, because I was used to having this big thing, right? This triathlon that you spend months training for, this big thing that you do, you know, this big effort. So finally discovered a 30-day Murph challenge, which is what I described, you know, a mile, 100 pull-ups, 200 push-ups, 300 squats, run another mile every day for 30 days. That was my first challenge.
It's crazy.
And it was, it was. And I had no training into it. I was not building up push-ups. I was not building up pull-ups. I just dove headfirst
Just
into it.
David Goggins stuff.
Yeah, I just, let's just do it. And it was incredible, I posted on my Instagram stories to just kind of keep myself accountable. And, I've only got like 400 followers, so it's not like I'm a fitness influencer or anything. It's mostly friends that follow me, right? So I would post on my story every day, and just because I knew if I missed a day, someone would message me, "Where was your Murph?" Right? So I did it to keep myself accountable. And day 5 was by far the hardest. I mean, everything was hurting. My chest, like I would have to hold my pecs while running so they wouldn't bounce because it was hurting so much from the push-ups. So like on my mile runs, I was going like this, right? And then my arms and my forearms from the pull-ups, and and I was just so incredibly sore. But then, one of the things I learned, your body's really good at adapting to things. So day 6, I started to feel better. It was still hard, but it was easier than day 5. And then it started to get better, and I started to get faster. My first Murph I did in the 30 days was an hour, just under an hour, I think, a minute or two under. By the end of the 30 days, I did a Murph, a mile, 100 pull-ups, 200 push-ups, 300 squats, run another mile. I finished it in 32 minutes. Because I was doing it every single day. And your body gets really good. The human body is amazing at adapting to things. I mean, you look at all the different kinds of athletes in the world. Your shot putters, your sprinters, your endurance runners. Whatever you kind of throw at the human body, it's really good at adapting to things. And that's something that first challenge taught me, was how quickly your body can adapt. And doing that challenge, I just got so much support from my friends on Instagram, which I was not expecting. All these people, like all these people stuck in their homes in quarantine, because I started this in like late March of 2020, right? And, sending me positive messages. I had local Davis friends join in on me, not COVID safe, whatever. But I had local Davis friends join with me to do these Murph challenges, so to do like one day of the Murph with me. And the outpouring of support, the friendships that were able to grow because of it, and just, the brutality of it, honestly, physically, was something that I enjoyed. I think it was awesome. It taught me a lot about what the body can endure, and what you can do if you give yourself a goal and you don't give yourself options. You say, this is what I'm going to do, and I'm going to get it done. You don't say, well, you don't give yourself excuses. The difference between a good excuse and a bad excuse is nothing. They're both excuses. So you just put excuses behind, and you do the Murph every day. Picnic day, Dave's huge party day was in the middle of that Murph challenge. And, we as a house were planning on, doing shenanigans all day. Well, I got up early and got my Murph done before I, drank all day and did whatever, right? So, you eliminate excuses and you just do it. And that was another thing that helped me was another thing I learned in that was the difference between discipline and motivation. The motivation comes and goes. Some days you're super amped to work out, and some days you're not. But what matters is if you have the discipline to continue to work out on your schedule, whether it's 5 days a week, 3 days a week, 6 days a week, whatever it is, you have the discipline on the days where you don't want to work out, you keep working out. So that was my Murph challenge, my first challenge I ever did. 30 days of Murphs in a row. And doing that and I got that same feeling after finishing that first triathlon, this big sense of accomplishment after the 30th Murph, and it just felt amazing. And okay, I want to continue to do things, do these kind of things. And I did. The next one I did after that was 1,000 push-ups in a day. That was one I wish I trained a little bit more for. This was still like before I started training for these challenges. So yeah, I did 1,000 push-ups in a day. It took me like 12 hours because I was doing really good. I got like 500 done in like 4 hours, something like that. I was making great time. But then I just started to get slower and slower and slower. Until towards the end, I was doing 1 push-up a minute. I was my body was so wrecked. But yeah, I did 1,000 push-ups in a day. I've done 1,000 pull-ups in a day. The one you had mentioned with the beer was, it's the 24, I think that if you look it up online, it's like the 24x3 challenge. It's like 24 hours, 24 miles. Maybe it's just 24x2. But it's for every hour, for 24 hours, you run a mile. So at the start of every hour, you run a mile.
Oh, I
for
remember.
24
Yeah.
hours, right?
That was the weird one because you had to wake up at night.
Right. So yeah, for every hour for 24 hours, you run a mile. But I was like, this was still quarantine. Let's amp it up a little bit. So every 24 hours, you run a mile. Plus, you have a beer. Plus, take a hit from a bong. And then I'm like, well, it's 24x4. Let's get a fifth. So plus, have a piece of bacon. Why not treat myself a little bit?
Yeah.
So that was the 24x5.
24 pieces of bacon.
Yeah. A lot of salt. Good for the electrolytes. Which I thought, with all those beers and all that bacon, I'm not going to want any more food. Nope. I was still hungry. So I ended up eating more in addition to all the bacon and the beers.
4 miles.
Yeah.
How long did it take you per mile?
It depends. Some were real fast, and I walked a couple of them because I started at 10 a.m. on a Saturday, and I was having an amazing day. I was running, I was having beers, and because they say like 1 beer an hour is like how long it takes one drink an hour is how long it takes for the alcohol to subside. It's more like an hour and 15 minutes. Because, I didn't really feel the first 6, you run and, you drink your beer and you run and you don't really feel it. And then it started to creep up on me, starting towards the evening. Like, okay, I'm starting to feel the buzz, I'm having a good time. And then we had people over that night and, I had buddies running with me, so up until like 10 a.m. to 2 a.m., spirits were very high. I had people running with me. People were over. It was a blast. 2 a.m., everyone goes to bed. It's 3 a.m. At this point, I'm drunk. And I have to drink another beer by myself at 3 a.m. and go for a mile run, have a piece of bacon, and take a rip from the bong. Right? It's like... So 3, 4, and 5 a.m. were brutal. They were no fun. No fun. But then I had a buddy.
How was the sleep between those? Did you?
I slept a little bit. You would take naps. Because you have to start the run at the top of the hour, and then if you're walking, it takes 20 minutes, right? So then you're like, oh. So I walked for those 3 miles, and it was. So it would take little naps, but I wasn't getting good sleep for sure. But yeah, and then 6 a.m., then the sun starts to come up again, so that's nice. And then I had buddies running with me again, and started to be all right. I don't know if I don't think I'll ever plan on doing any alcohol or intoxicant relating one. It was fun to do that in college, but it made it
unnecessarily.
Yeah, it was kind of made it like unnecessary, and it's kind of like sickening, and then with the hangover. I mean, I was hungover for like 36 hours after that one, after having 24 beers, and so that it was fun, and I'm glad I did it, but I have not done an alcohol fueled one since. But yeah, 24x5, I did a 12-hour spin bike, so 12-hour on the stationary bike where you hook your back wheel up to like a rolling thing, and I sat on the bike inside my apartment for 12 hours. I've done these things to challenge myself, and a lot of them I've raised money for charity. I've raised a couple $100s here. in that time between graduating and starting my work, I biked from Davis, California to my mom's house in Glenwood Springs, Colorado. 1,550 miles over 21 days. I averaged 70 miles a day. I ended up raising $1,750 for charity, all going to the Equal Justice Initiative. And so that was my first sort of charity fundraiser. You know, it wasn't. I guess I could call that a challenge. I mean, it was physically very challenging.
I'm pretty sure qualifies.
You'll allow it. Thanks. But yeah, I mean, that was I don't know, maybe the greatest thing I've ever done was that bike ride.
So far.
Yeah, 21 days, all solo, living off my bike, stealth camping. You know, I stayed in a hotel 2 nights of the 21 days. Everything else was side of the road, baseball dugouts, community college lawns, parks, ditches, you know, wherever. Just throw the sleeping bag and sleep the night.
No tent?
It was summer. Didn't need a tent. Yeah, no tent. But yeah, so that one was incredible. I mean, it taught me a lot about, you know, the geography of the Southwest. And it was it was such a pretty bike ride. Southern Utah is amazing. Yeah. Even northern, you know, I biked across Highway 50, the loneliest road in America is what it's called, and that was gorgeous. You know, just I felt like I was one of the original pioneers, because I would bike into these valleys, you know, drop down from a climb, and there's just nothing. You know, it would be like, you know, dropping down into Silicon Valley from the Santa Cruz Mountains, and imagine there's not a single building. There's just nothing. You know, those are the kind of valleys I would see. I mean, obviously not with the Bay water, but like the size of valleys of just nothing. It was incredible. I'd never seen anything like it before. And just the one road in the middle of it. It was incredible. So you know, that challenge, that bike ride, you know, it taught me a lot. You know, it gave me a really unique perspective on homelessness, actually, because, you know, I had mentioned I was, you know, lawn of the community college, baseball dugouts, like just so I could find shelter, right? And, you know, I would get nervous, like if I was sleeping in a park, like I would see a light, like, oh shit, is it a cop? You know, okay, no, I'm fine. And, you know, because, you know, look, I'm just trying to sleep the night, you know, I'll be off on my next place and, you know, starting the next day. And, you know, I realized, you have that, you know, when you don't have a place to go home to every night. You know, I'm fortunate to be living in a house. You know, if you don't have a place to go home to every night, how much anxiety and stress that gives you, you know? And, you know, I had the excuse of like, hey, I'm, you know, on a bike ride, and, you know, so I had some excuse there. But, you know, if you're in the same town all the time, and, you know, so it gave me a unique perspective that way. And then, you know, also a woman I had talked to on my journey who, it was in the middle of a day, it was like 105 degrees, and, you know, I'd done like 60 miles, I had another 25 to go. But it was like 105 degrees out, and like I need to take a break. So I hung out in a gas station for 4 hours and just talked to the owner of the gas station. Just me and her for like 4 hours, just talked. And, you know, she was in the middle of nowhere, Utah, 70 miles each direction to the closest city. How does someone end up there? How do you end up working in a gas station, literally in the middle of nowhere, 70 miles from, and it's not like 70 miles from big cities, 70 miles from like towns of like 200 people, right? Literally just out in the middle of nowhere, and talking with her and how she became homeless, how she started from like, she started in like a decently wealthy family, and, you know, and rose her way up, was like some, you know, a finance executive in Chicago, and had a couple cars and was doing well. And, you know, and one of the unfortunate things about this country is, you know, our healthcare is tied to our job, right? And if you don't have a job, you know, you don't have healthcare. And she got really, really sick. And because she got really, really sick, and they didn't know what it was, so she couldn't work, and she lost her job because of that. Well, she lost her job, she lost her health insurance, and the medical bills got more expensive. And then, so, you know, she had to sell her stuff. She had to get into a smaller place. And then, you know, her parents died, and her brother like wrote her out of the will, so she got nothing from that. None of that generational wealth. So,
It's like an out of control feedback loop.
Right. So she got no support from family, and then she'd get more and more sick, and more medical bills, more and more debt. And then had to bounce around, try and find how do I work part time because she's so sick, and they finally figured out what it was. But hundreds of thousands of dollars of medical debt later, losing her career, losing her family, losing everything. So homelessness can really happen to anyone. So, that gave me talking with her was life-changing. It really was. So, that bike ride, that's why I say it was, one of the greatest things I've ever done was just all the people I met on the way, the people you talk to, because the towns I was staying in were, towns of 100 people, 300 people, 500 people for a big town. One town was 30 people. You don't just end up in a town of 30 people, right? You have a good story. You end up there. So talking with those people was incredible. And the bike ride was incredible.
There was a great story of how you got help with that. At the very end, right? There was
So it was day 14. So this was 2 weeks into my 3-week journey, and I was in Escalante, Utah, and I was 6 miles out of town, and the spoke on my back wheel broke, and it was a bad break, and it caused my wheel to bend too. So it wasn't just the spoke fall off, but the spoke, when that fell off, it bent the wheel. So lift it off, it just wouldn't spin. And so I needed a new wheel. The wheel was completely shot. So I hitchhiked back into town, and did some searching around. The closest bike shop was 150 miles behind me in Cedar City, Utah, or it was 400 miles in front of me at my final destination. So, okay, so how am I going to get there with a broken bike? And so I there was a motorcycle repair guy in town, and sat and talked with him, told him my story, and he had stuff for motorcycles, but he didn't have a spare bicycle wheel for especially for the road bike that I had. And so we talked for a little bit, but there was nothing he could do. So I knew my mom was in Colorado. That was my final destination, and I called her, and I was tears, because I was raising all this money for charity, right? I had this big adventure that was 2/3 of the way through. I felt like, I could see the light, like I'm really going to do this thing, right? 2 out of the 3 weeks in, and then to just have it completely stop because of a broken wheel. So I called my mom. I said, "Mom, you got to pick me up. I got a broken spoke, and I'm hundreds of miles from the closest bike shop. There's literally nothing I can do. I'm in a town of 700 people, and there's no bike shop here." And so I said, okay, credit to my mom. She's an amazing woman. She said, okay. So she started the 9-hour drive out to get me in Utah. So go to the one restaurant in town, and complaining to the waitress, it's like, "Oh, how you doing?" And I'm just so sad, obviously, and just venting everything to the waitress. And I'm in this big trip. I'm raising all this money. I'm on this amazing journey, and just to have it end. And there's one other family at the restaurant, and it's a husband and wife and their 2 kids. And the dad overhears me, complaining and just being very sad. And he says, after the waitress comes, he comes over and says, "I can drive you to the Cedar City bike shop if you want." And I was, no, it's my mom's coming. No. Are you sure? It's like, yeah, no, it's fine. I eat my meal, I'm sad, having a margarita. And he comes over at the end, he's like, "Are you sure you don't want me to drive you to that bike shop?" I mean, me and my wife are both teachers. We're on summer break. We're on a 6-week vacation into the Southwest. We're not really planning things, for that long. So it's like, it's kind of a do whatever day tomorrow. We can leave early in the morning and I'll get you to the bike shop and we'll drive you back. And I started to think about it, like, maybe we could actually do that. And so this guy, Jason, who I've kept in contact with, next day, bright and early, 6 a.m., we leave, drive 150 miles back to Cedar City, which was one of my stops like 4 days earlier, right, on the bike. But it took me like 2 hours on the car, right, 2-3 hours on the car, whatever it was. So drive to Cedar City, go to the bike shop, get a new wheel, put it on. He drives me back to Escalante. Plus, he gives me a 50-mile boost to make up for lost time.
For the day that you weren't...
Right,
Yeah.
to make up for lost time, because because I was supposed to end my day not in Escalante, but like 20 miles in front of Escalante. So I was behind that, plus the time of going back and forth to Cedar City, because I started my day every day at sunrise. It was really cool, going sunrise to sunset kind of a thing, to sleep with the sunrise and sunset. I would, because I didn't have like a home or a hotel where you have like screens and artificial lighting. I would fall asleep with, at sunset and wake up at sunrise. It felt really good. Honestly, it felt
in sync.
Yeah, I really did. I totally got the circadian rhythm. It felt natural. It felt right. I really liked how I felt.
Did you feel groggy in the morning at all?
At first, but and my body started to take a toll towards the end, because the most I had ever ridden on a bike is like 200 miles in a week. Before that, I was doing 500 plus miles a week doing that, and not taking any days. I took 1 day off in the 3 weeks. Halfway through at Zion National Park, I took 1 day off. But other than that, I was biking 70 miles every day, and that's just on average. Some days it was 80, 90 miles. Some days it was shorter, but it was. And if you look at the topographical map of the United States, all of the United States are all of the mountains in the United States are Colorado and west. You have a couple mountains at the Appalachian, on the very tip of the East Coast, but all the other mountains in the United States are all Colorado and west. I had to overcome this. I'd go up and over the Sierras, Nevada and Utah. I mean, Utah is a hilly state. I had no idea. Utah, and it's all like high desert too. And Utah, the elevation change in Utah was crazy. And then obviously the Rockies in Colorado, a ton of climbing there. So, yeah, physically brutally challenging. And towards the end, I could really feel it taking a toll on my body. And that's really when I started to amp up the caffeine. I'm not on a typical week, like, I don't have coffee to start my mornings. Like, I have coffee, or coffee, caffeine, whatever, once a week. And it's usually if like I'm feeling groggy for a workout. I don't really have the need for caffeine. I was having like 3 cups of coffee a day, minimum. I was having energy drinks. I was really using the caffeine to my advantage. Really towards, especially in that last week, I was slamming 300 milligram caffeine energy drinks to get me through those days. But yeah, and then that feeling again, finishing that bike ride, showing up to my mom's place, and having her there, and my brother was there, which was really cool. And that's one of the things why like it wasn't why I wanted my mom to pick me up is like my brother was only there for a short time and I wanted to see him. It's like I gotta get there, right? And that's what also motivated me to keep up that pace of biking is, I really wanted to see my brother. And so physically, obviously very challenging, 70 plus miles a day, or average of 70 a day, but, and then an average of 3,000 plus feet of climbing every day. I mean, there's a lot of elevation change going from California to Colorado, up and down, up and down, up and down. So yeah, it was incredible. So yeah, he drove me back 150 miles to Cedar City to Escalante, plus the 150 mile boost. Wouldn't let me pay for gas, wouldn't let me pay for his coffee, wouldn't let me pay for his food, nothing. Just being a nice dude. And that totally like restored my faith in humanity and just was like, there are good people, and totally made me feel good to be a human being. and was just an amazing experience. Just at the kindness of his own heart, he's on vacation with his family, spends an entire day with some random person he doesn't know, and saves his journey. And just beyond grateful to Jason, and such an amazing guy. He's a science teacher in Ohio, and I commissioned one of my good friends to. I took so many pictures on the trip because, oh my God, so pretty. That entire trip was so pretty. Every day I was blown away with how pretty that trip, because it's all like scenic byways, right? I wasn't biking on the interstates, right? I was biking on, the first highways that were built in these states. And it's all through these beautiful mountains and all, all this really pretty stuff and all these windy roads and all this, because it's, because you don't want to be biking where all these cars are, right? Yeah. So yeah, that's what I did, and it was so pretty, and so I'm hoping next summer. My hope for now is next summer I want to finish my trip across the United States. Is to start at my mom's. Actually, one day before my mom's place, because I would have to backtrack a day. So, why waste a day? So start in. Blanking on the name of the town, but somewhere in middle Colorado, and bike east. I think I can do it in a similar time frame because, like I said, I've already done all of the climbing in the United States, so it'll be flat for the rest of the way. So I think that'll allow me to get some higher mileage in per day, even though it's a little bit longer in terms of mileage. I think because it's all flat, it'll allow me to go a little bit longer.
Is that one of these bikes, or?
Yeah, my purple bike over there. My Purple Princess Andromeda.
Oh, that's right.
Yeah. Take her and continue the journey across the United States. Is hopefully, if I save enough money and I get things right with scheduling and all that, I think I can do that next summer. Save up the vacation days, all that kind of stuff. But yeah, so now I'm doing 75 hard, which is another challenge. Let's see, what are the other challenges I've done before 75? I did a 30-minute plank. I hated that one. That was by far my least favorite one. That, because it was just...
How many days?
A 30-minute plank. So
30-minute plank
30,
once?
Just, yes, in a row, a 30-minute plank. Yeah, and it took me 8 months to train for that. Brutal. Because I would also take time, because it was mentally the hardest one. Because the 1,000 pull-ups, and I love pull-ups. My favorite upper body exercise is a pull-up. I think everyone should do pull-ups. So I really like building up to the 1,000 pull-ups. That was when I trained well. I did 100 pull-ups in a day. Then I did 2. Then I did 4. I built up to the 1,000, right? And I enjoyed that process. I hated every fucking minute of training for that 30-minute plank. Every minute. It was so painful, because no matter how good you get at planking, it's just the same burning sensation in your stomach. It just burns and it hurts, and it's just so painful.
But also, it feels like you just have to suffer and wait. You don't have the act of doing and focusing on something.
Yeah, and the 1,000 pull-ups in the day, right, is I was doing, I think, 4 pull-ups a minute for the first 6 hours, right? So I'd do the 4 pull-ups, and then I got to sit down, for 50 seconds, whatever it was, have some water, talk, whatever it was, hang out. It is 30 minutes straight of being uncomfortable, just no break, just no release of tension, and I got to 10 minutes, I got to 15 minutes, I got to 20 minutes. So I would build it up as well, but it never got comfortable. It was excruciatingly painful the entire time.
When you got the 30-minute one, when did it become painful? Minute 1? Immediately?
No. So, no.
But you would enter that.
When I was able to do the 30-minute plank, and it was also weird because it would vary so much day to day. I was forcing myself to plank, I was doing a little bit here and there, but, towards the end, I was wishy-washy, but I would take 2 weeks off because I hated it so much. That's why it took me so long. And then I really all right, I'm going to buckle down. I want to get this thing over with. And so I was doing it every day. So I was forcing myself to do at minimum a 5-minute straight plank every day. And, there were days where a 15-minute plank was easy and it was no pain. Then, a couple days later, a 15-minute minute plank was brutally painful, and I could not figure out why. Some days it felt good and some days it didn't. But yeah, when it comes to the 30-minute plank, around the 15-minute part, where it was like, it is very painful, and it was the point where like, okay, I want to quit, at that 15-minute mark. And yeah, but then I just that one was the deepest and darkest points I've ever got in my mind. I was listening to David Goggins, I was listening to him yelling at me and just just doing that kind of stuff, and just pushing past those barriers of you get to a point where it's like it hurts. You feel that in workouts where it's like it hurts. You do 10 reps, whatever. It's like okay, but whenever you get that, you can always do more. You can do 10, you can probably do 11. Unless you're really like shaking and did that 10th out. If you're doing 10 full reps, like, okay, yeah, you can probably do 11. You can probably do 12, And so I would do the plank, and I'll get to 10 minutes, like, okay, I can do another 10 seconds. I can do another 10 seconds, And it was just, and getting to those deepest, darkest depths of my mind and really exploring that and really pushing past that, and just doing something that I hated doing, and just working so hard at it, definitely the happiest I've ever felt after one of these things, because having that behind me, oh my God, was it amazing.
So did you try to get it like behind totally, or in the day when you were trying to train for it?
What do you mean?
Do you mean like you would dread having to do it the day?
Oh yeah. I dreaded training for it. But
it feels good. Like, okay, today I'm done with this.
Yeah, but once I was like actually done with the 30 minutes,
30
like,
minutes.
oh my
Okay.
God,
Yeah.
the happiest I've ever felt after a challenge was finishing that 30-minute plank, because of how brutally painful it was. But that's part of the reason why I do all these challenges. One of the things I think is really valuable in these challenges is the difficult nature of them, the physically difficult nature of them. I think is really good for the mind, because in our normal society, the average person does not do anything physically strenuous. Most people don't work out, period. And then if they do some workout, it's usually very casual. But doing these extreme things that I've done, going from being I was at a triathlete, I was in good biking shape, but then biking 1,500 miles straight, and my body could take it, and doing no training and just doing 1,000 push-ups in a day, and my body could take it. And or these things where you train up to, or I did more training and building up to these things, doing these things that are so difficult, so mentally and physically difficult, then everything else in life just seems easy. Your scuffles at work seem meaninless. The task you have at work, where it's like, oh, I gotta figure out this component and how it works. It seems trivial. Yes, it requires mental energy, and yes, it can be difficult, but when you do these really difficult things and you realize what something that's actually difficult, something that's actually stress-inducing, when you
painful.
Actually painful, and you experience those things and you confront those things heads on, then you get this confidence from it that is unlike anything else. Now, looking at things, I think confidence means a lot more when you have something to back it up with. You can be like, yeah, I'm a strong guy, but when you have when you can have things to look back to, it's like, look at these 20 triathlons I've done, or look, I've done 1,000 push-ups in a day, I've done 1,000 pull-ups in a day. When you have these things to look back on, not only do you have confidence, but you have something to back up your confidence with. It's so much easier to have confidence when you can point to concrete things to back it up with.
Outwork the self-doubt.
Yeah, exactly. Absolutely. Well said.
That was, I think, Alex Hormozi.
Okay. Yeah. So when you push past these breaking points to where you don't think you can accomplish these things, and you accomplish these things, do these very physically demanding, hard things, I think it makes you just a better person. You know, it makes everything else in life. You're running through financial trouble. Well, you buckle down, you get through it. You know, you get what needs to be done. You're in a stressful time in work, you buckle down, you get through it. You know, you see what you need to do and you do it, you know? So doing these really challenging things, I think is really good for the mind.
Yeah.
And, you know, you only grow, you know, the body only grows in stress. Muscles don't grow just by sitting down and taking steroids, you know. Muscles grow because you're pushing weight, you're pushing your body under stress. I think the mind is the same way. So when you put your mind through these big stressful things, I think you grow as a person, and you overcome these stressful, challenging things. I just think you get stronger mentally, physically, and very much spiritually as well. You have this confidence, you have this enlightenment, you know, to where, with the planking, you know, I would plank for 5 minutes. Like, I can't do a second more. It's excruciating pain. I'm literally shaking while planking. I'm dripping sweat. You know, I didn't know you could pour sweat while planking, but I learned that, you know, shaking, burning. You know, I feel like someone's stabbing my stomach, and I could go for another 5 minutes. But you have to, you know, ignore that and push through that pain. And so these challenges have taught me so much and given me so much, and, you know, and yes, I post them all on my Instagram, but, you know, it's mostly to keep myself accountable.
Yeah.
You know, and it's and, you know, to make
it doesn't look like it's for show,
right?
Yeah.
You know, I'm not taking sponsored stuff. You know, I'm not that anyone has reached out. I probably would if someone reached out, but no, it's.
I think it looks authentic and sincere, doesn't?
Yeah, and I definitely get that from people. I've gotten so many messages from people, you know, people you friend on social media in middle school that you never talk to again, right? I'll get messages from people like that, like, you know, you have inspired me to, you know, like during the Murph Challenge, you've inspired me to do 20 push-ups every day. That's awesome, you know? Or, you know, when it's raising money for charities, you know, at this point I've raised, you know, probably, definitely over I'm probably approaching $5,000 I've raised in total over to various charities. You know, and that feels really good. And to have all these people from all different points of my life, from elementary school to college friends to, you know, current coworkers, all donating, you know, to these goals I'm reaching. And to have, you know, just so much support. And, you know, when I'm really down in the dirts and like, you know, like for the 30 Murphs in a row, like, I don't think I can do anymore. I'm in pain. And just all the messages of support, you got this. And just the genuine connection I would get from a lot of people. It's really been amazing. Just the amount of support, that I've gotten. And, you know, I get messages like, hey, you know, like, what would you recommend? Or like, I want to start getting into this, and, you know, helping people on their own fitness journeys has really been fun, you know. And because, you know, I only have, you know, 400 followers, and, you know, only a quarter of that, if that, interact in some capacity, it allows me to really have, you know, connections. And
wait until this podcast goes live.
Yeah, all your millions of subscribers. But, you know, it allows me to, you know, keep in contact with people that, you know, I would have totally lost contact with, you know, like these middle school friends, you know, that I'm talking about, these high school friends that I would have otherwise completely lost contact with. But because I'm doing this, I'm able to have, you know, I will send messages, you know, a few times a year, and, you know, get to interact and just give shows of support both ways. So these challenges have enriched my life in so many ways, you know, physically, mentally, you know, spiritually, you know, the emotional connections that I've made, the journeys that I've been on, you know, what I've learned about myself, you know, as a person, you know, doing these challenges have been so rewarding and have taught me so much. And I've gotten that a lot on my current one. So I'm currently doing 75 hard. Like you mentioned, I'm on day 62, so I'm almost done. And it's 75 days of 2 workouts a day, 2 45-minute workouts a day, one of which has to be outside. a gallon of water every single day, read 10 pages of a book every day, no alcohol. I took it to, no intoxicants whatsoever. So completely sober for 75 days. Follow a diet of some sort. So I'm doing no desserts, sweets, or fast foods. So none of that. And so yeah, I've got the water, the 2 workouts, the 10 pages, the diet.
No cheating.
And staying sober. Oh, yes. And then no cheating and no exceptions.
No cheating on any of those.
Yes, no cheating on any of those and no exceptions. No, like, okay, well, what about this? No exceptions, no cheating. And it's been awesome. It's another way of, I'm a firm believer that taking a day off is good in terms of a fitness plan, at least one day off, depending on what sport you're doing. For World's Strongest Man, they're working out 3 or 4 days a week, because they're lifting such heavy weights, right? But for the general fitness enthusiast, I think a good workout plan is working out 5 or 6 days a week of some activity and taking a day or 2 off. I think that's a very healthy way. It reduces the risk of injury. It allows you, if you're looking to grow muscle, having that rest day is super important, because that's when your muscles grow. That's or not necessarily get bigger, or if you want to get stronger. Some people just want to keep the same size, but want to get stronger, right? Again, that day off of rest is very important. But it's been 62 days and I haven't had a single day off.
How are you feeling?
Body feels great.
Yeah.
It's not the most optimal fitness routine. If I was, if I had specific goals, if I'm trying to become a better triathlete, or I'm trying to grow stronger, be a bodybuilder, whatever it is, taking no days off is not optimal. But your body can handle it.
You look leaner and more muscular.
Oh, well, thank you.
Since we met on the New Year, right? Before you started, right?
Yeah, no, I started January 15th.
Okay, yeah. So we met like a couple of weeks for Christmas.
Yeah, for Christmas. Yeah. No, yeah, I've definitely leaned out. I've actually, funny enough, I've kind of kept the same body weight, but I've looked leaner. So I think I have gained some muscle. I've dropped a couple pounds. I think I've dropped like 4 or 5 pounds at this point. But I've definitely, like, I don't know, like you said, a little bit more showy with the muscle. So, so yeah, no, that's, it's a fun side effect. But I've really enjoyed the reading. The audiobooks are great. I'm a big proponent of audiobooks. I listen to audiobooks. But there's something different about just sitting down and reading a book. And 10 pages a day really isn't that bad. Think about like for most people, hours a day they spend on social media.
Just scrolling the shorts.
Scrolling the shorts or the TikToks or on Instagram. Just that endless scroll.
Twitter,
whatever social media it is. And then, think about, can you name the last 10 YouTube shorts or TikToks you watch? No. It goes in and it immediately goes out, right?
And it feels terrible, because I feel after a certain time like I ate fast food for my brain.
Yeah.
I'm not sure what I was looking at or focused. Just a little bit sort of unfocused in my mind. Mental clarity just not there.
Absolutely. Yeah. And I feel like that goes, your attention starts to shorten, and I'm, feeling those side effects of where it's like, like you're always like any quiet moment, right? You got to pull out the phone, right? You gotta scroll at something. But so yeah, just sitting down, so 10 pages, it doesn't really take that much, 10 minutes, 15 minutes, easy. Everyone spends that on social media every day, right? So 10 pages a day really isn't, that much of a time sink. But then, that allows you to read a 400-page book in 40 days. And that's pretty good.
So you can get like 10, 11 books per year.
Yeah.
If you read this much.
Let's say an average book, is 300 pages. That's 12, around 12 books a year. And that's just reading 10 pages every day. And just, like, wow, I'm really moving through these books. And it's like, oh, it's actually only 10 pages a day. So I've really enjoyed the reading, and a lot more than I was expecting to, and just sitting down and reading. And it's a lot more satisfying finishing a paperback book than it is an audiobook. It's just something about, I don't know what it is, but I just a lot more feel that sense of accomplishment finishing a real book than I do finishing an audiobook. So really enjoying that. The water's getting to me. I'm not gonna lie.
Do you want to?
I really struggled. No, not now. No, I'm fine. But no, at the beginning, I really struggled with the water. I mean, I could not sleep through the night. It was miserable. Now I'm pretty much every night I sleep through the night with a gallon of water. And
You have to drink it before you go to bed, or
just throughout the day.
throughout the day. Can you start like up front?
Yeah,
Try to drink
whenever.
more?
Yeah, and that's why I like my morning workouts, because it forces me to drink a lot of water early. But yeah, so I drinking a lot of water. Like I said, at the start it was tough. For now, it's just like I have to, not necessarily that it's difficult now, but I have to be on top of it, because it's very easy to go, shit, I haven't drank water in a while. It's 8 p.m. and I need to finish a quarter of a gallon. It's very easy to do that. So it's, I have to be on top of drinking water throughout the day, which, isn't too bad. But at the start, that was really tough. 45-minute workouts haven't been too bad, but also I haven't been doing, to keep the sense of longevity in mind. It's not like I'm doing, a max squat workout, then a max deadlift, and then I'm doing max arms and max shoulders. I'm doing, like today, for example, I currently cannot do a muscle up. It's something I've always wanted to do. So I did some muscle up training, some pull-ups and then some assisted muscle ups. It's my first workout. And then I'm dealing with shin splints right now. So I did like lots of calf raises and heel raises and like kind of like physical therapy type exercises as my second workout. Every Monday I do yoga, so not every workout has to be a super hard strenuous workout. Most of them are two proper workouts, but I'm also throwing things in there that are, what someone would consider more like recovery workouts, or like physical therapy type exercises, single leg stuff, balance type stuff, to make it so I can, survive 75 days without taking a day off.
And one of those workouts has to be outside, right? Yes,
one of those days had to be outside. I've been able to time the rain pretty good, so I've only had to do like 2 or 3 rainy workouts, even though it's been raining a lot in California this year. I've been able to time the rain pretty good, but and that's nice too, just being outside more and just doing like a regular workout that I would do in the garage, doing that outside is super nice. And just if I'm lifting outside, or like my stationary bike, doing the stationary bike outside, it's really nice. It's an extra 10 feet that way, but I'm getting sunlight. I'm getting a lot more fresh air. It's awesome. So definitely has shifted my perspective. Like, I should do more lifting outside. That's nice. The reading's been great. The water's been fine.
So are you keeping some of those things just in general?
Yeah, I definitely want to keep reading more. I don't think I'll be reading 10 pages every day, I'll be honest with myself, but I definitely want to keep up the reading in some capacity. I want to be working out outside more, whether it's my lifting or my trainer rides, keep those outside. It's really nice to get that sunlight. The water, I wasn't drinking. I kind of figured I was drinking around 3/4 a gallon every day, versus now I'm drinking a gallon every day. So I wasn't really dehydrated. So I'm not gonna force myself to okay.
Drink.
Because now I am very on top of I have my 32-ounce bottle of water and I make sure I drink 4 of those every day. So I won't be as anal about that kind of stuff. And then the last part has been the completely sober part, which has been really interesting. It's funny to say that, I haven't been sober for a big stretch of time in a long time, because just in life, you have a beer or two, you have, a couple drinks on the weekends, I never really drank during the week, but, you do, it's usually weekend stuff, right? You do stuff, most weekends. And then, it just, you're kind of regularly doing it, and every social occasion you're always or at least in my case, in a lot of cases you're having you know, some sort of alcohol or weed or whatever it is. So you're doing something, you know, on social occasions, and then just completely cut it out, and to be completely fine with it, and like, this is fine. I'm still enjoying social occasions. I'm still having fun with my friends, and people are really happy with me because I'm the designated driver, you know. So no one has to pay for Uber, so I'm saving everyone money. And so it's made me think that, you know, like those times where, you know, you're having like 1 or 2 drinks, or it's like you're going out to the bars on a weekend. It's not like a special occasion. It's just like hey, it's Friday, you want to go downtown San Jose? It's like, it's made me think like, maybe I'll just a lot more of those nights just not drink, you know, because then you feel much better the next day, you know. And not that I had an unhealthy relationship with any intoxicant before this, but to go completely sober and, you know, forces myself to think a lot more, because I'm not like, you know, distracted, you know, because these intoxicants sort of like take you out of your own head, right? So it's forced me to be thinking a lot more, which is interesting.
And no substance. You pretty much prove to yourself that you're not dependent on any substance.
Right. You know, it's zero substance to prove myself. You know, I'm fine without substances, and to force that, you know, I can still have a good time without any like, we're hosting a baby shower tomorrow. That's why we have the diapers in the background.
That was just for me.
And to do that and be, you know, and not be worried. I'm just, I know I'm going to have a great time tomorrow. There's going to be a bunch of friends over, and I'm not worried that, you know, I'm going to be sober all day. It's going to be completely fine. And so it's, you know, it definitely has shifted my perspective on any type of, you know, intoxicants, substance, all that kind of stuff. And, you know, shaped me into, you know, I definitely think, you know, moving forward in terms of like, you know, the casual one drink thing, or like the casual, like it's a random Thursday. It's like, well, I don't need to drink. Like, okay, if everyone else is going to have a beer, it doesn't mean I have to have a beer. You know, it's okay to just not join in, you know, which, you know, I'm talking to someone who doesn't do any substances, right? So it's probably funny to hear this side of the conversation.
It makes sense to me. I've been there. I do drink Diet Coke sometimes. I feel guilty about it.
That's not a real substance. I mean, it's something that alters the mind, you know.
Like kvass, the Russian
soda, yes.
Yeah.
But yeah, so, you know, that is sort of the spiritual thing I've gotten out of this challenge is, you know, confronting, you know, sobriety and what that's like, and what that perspective is like, oh, it's actually completely fine, and it's not reducing my enjoyment of things. And, you know, not that I will, you know, continue to be sober after this. You know, I know on day 76 I'm going to have a drink, but I'm not going to get drunk on day 76. I'll probably have a cocktail, you know, certainly because I want to ease myself into it too after, you know.
It's probably going to hit stronger than...
Exactly. But no, and so, you know, that perspective on, you know, maybe I just don't need to... You just, the regularity and the nonchalantness and the norm of drinking it's so prevalent, you know. It's every day, you know. It's like, let's grab a drink. Or it's like, now I'm doing coffee dates, you know. It's much nicer.
Or happy hour at work.
Happy hour at work, or whatever it is, you know. Just having, just not doing it is it's honestly been refreshing. I've really enjoyed just taking a step away from all that kind of stuff. So. 75 hard. It's God's It's Good for name for a reason. My housemate Evan was doing it with me, but he quit on day 41. He said it was affecting him, and just he couldn't recover, and it was causing him too much stress, and so I applaud him for trying. Yeah, I mean, it's called 75 hard for a reason, you know, and it's something where it forces me to be really conscious about my scheduling with my workouts. It's, you know, it's like, okay, you know, it's like, if I know I'm busy after work tomorrow, it's like, well, I got to get up early and do 2 workouts, you know. There's no ifs, ands, or buts about it. And I really like these workouts. You know, the 10,000 kettlebell swing challenge was similar. I like these month plus workouts where it's like, this is what I'm doing today, period. It's not like I'm going to do non-work out, or like, I don't have to work out today. I can work out tomorrow. It's like, no, this is what I'm doing today. This is what I'm doing the next day, and I'm doing that every day. I just that structure of having no excuse. This is what you're doing. Just that discipline, that schedule. It's really refreshing because it takes all of the choice out of it. It takes all the excuses out of it. It takes all the BS out. It takes all the, it takes all that out.
Do you think there's a world where that challenge is harder with a day off in the middle, like every week, like Sunday off? Because you would break the structure and then you have to come back to that instead of you just so firm on it that.
Yeah, I think so. Yeah, I mean, I think if I was allowed to have a cheat meal every Sunday and I was allowed to load up on pizza and ice cream every Sunday, I think it would make the other days harder. Like I was mentioning earlier with the body's adapting. My body is adapted to where I'm not really having those cravings for the junk food, the sweets, the alcohol, and that kind of stuff. Once you step away from it for a while, you're okay. I'm not having it. Your body just gets used to it. So yeah, I do think if I was able to do it like once a week or once every 2 weeks, whatever it was, I do think honestly it probably would make it harder. At least for me.
Yeah. Final question, unless you want to talk about something else. That a couple years ago you said your favorite motto or quote would be "sick discomfort." Is that still? I mean, it's true still to this day. I'm pretty clear. I can see that you like that probably. Yeah. But is that your favorite right now?
It is a good one. Seek discomfort. I think with whether it is fitness, finding those uncomfortable points and like, oh, I can still do it. I think it's great. I think it's great for traveling. I think if you're like, you go to a country where they don't really speak much English, it's awesome. And you go to some hole in the wall restaurant there that there's no English on the menus, but I'll take that, whatever that is. And that's getting out of your comfort zone. I think is really good because I think that's where you grow when you experience things you would have never experienced before. If you're only in that bubble of what you've done before, you limit yourself to so much. So yes, I still do love seek discomfort. But if I had an updated one, I don't know.
It doesn't have to be like precise or concise.
Yeah. Seek discomfort. I don't know. If I had, it's hard to boil it down into one phrase. There's lots of good quotes. Jocko Willink's thing is discipline equals freedom. Which if you have that discipline, if you really have that discipline structure to life, it allows you to do more things. It allows you, if you have those consistent workouts, it allows you to be in better shape and allow you to have a more schedule. And if you work out every day at 6 a.m., then every afternoon you're free. And that kind of stuff. Or having that discipline takes away that motivation. And I don't know if I can. I'm trying to think of other quotes or things I've listened to recently, but I have a shirt that I wear in my challenges. I sort of have like a challenge shirt that I don't wear it any other times besides a challenge. And it says "Embrace the suck." That's another good one. And I guess that's more. It's a similar vein. Seek discomfort, embrace the dusk, but just going head first into the unknown and forcing yourself to do hard, challenging things. I just think is so good for the mind, body, and soul. And I think the body, mind, and soul only grow in areas of stress. whether it's physical, emotional, spiritual stress. When you have that, when you put that stress on your body, I think that's when you grow and become a better person. And I don't think you should shy away from that.
That's beautiful.
Thank you.
Thanks, Aiden.
Thanks, Emil. This was wonderful.
Likewise.
So tell me more about your life. Tell me more, tell me more. So tell me more about your why. Tell me more, tell me more. So tell me